سعادة رئيس القطاع الغربي، أيها الحفل الكريم، تبدأ الآن الجلسة الأولى من هذا الملتقى، والتي عنوان كفاءة الطاقة الكهربائية، ويترأسها المهندس خالد الطائمي.
بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. أيها الأخوة الحضور، السلام عليكم ورحمة الله وبركاته. صبحكم الله بالخير جميعا. الحقيقة لي الشرف أني أبدأ أترأس أول جلسة في هذا في المدينة المنورة طيبة. فالحقيقة شرف كبير لي يا أخوان. عندنا كما ذكر الأخ قبل قليل عنوان الجلسة هذه كفاءة الطاقة والإلكتريكال باور افشنسي، وعندنا 4 متحدثين إن شاء الله. وأنا تكلمت مع الإخوان قبل على أساس الوقت يا إخوان، كل واحد عنده تقريبا 20 دقيقة إن شاء الله، وأطلب من الجميع إذا يسمحوا لي تقريبا في البداية إنه جميع الموبايلات يا إخوان إذا قدرت تحطونها على السايلنت أكون لكم من الشاكرين، وكذلك المتحدثين الرجاء يعني يقفلوا جوالاتكم إن سمحتوا. وبعدين الأسئلة إن شاء الله نتمنى تكون في الأخير بعد المتحدثين ال4. اللي عنده سؤال يحاول يتذكره أو يسجله إن شاء الله. فنبدأ بسم الله الرحمن الرحيم. البرزنتيشن الأولى حتكون عن Network Automation Tool for Improving the Network Reliability Indices. البرزنتيشن حتقدم من بروفيسور سالم الخضري. He's a member of the board of the Faculty of Engineering in Ain Shams University and the director of the Consultation Center. Professor Salim is an energy expert for European Union, US Agency for International Development, United Nations Development Program, European Investment Bank, and KfW Development Bank. Professor Salim, تفضل.
بسم الله الرحمن الرحيم. السيد رئيس الجلسة، السادة قائدي وقادة الشركة السعودية للكهرباء، ببدأ كلامي إن أنا أشكركم على دعوتي وأني أكون في هذا الحفل في وسط نخبة جميلة من المهندسين. وهنبدأ الموضوع بتاعنا اللي هو Automation of Electrical Power Network عن طريق عدة وسائل Practical Cases. بنبدأ البرزنتيشن بتاعي. هنتكلم عن Introduction سريع والريلايبيليتي Indices اللي ابتدت تطبق في جميع أنحاء العالم. هنتكلم عن Determination of Reliability Indices، ونتكلم عن Methods of Improving the System Reliability. الحقيقة إن إحنا هناخد Practical Case لأحد النتورك الحقيقية. النتورك بتتكون من سيستم بهذا الشكل، وبتتغذى بعدة من هاي فولتج باور ستيشن ولميديوم فولتج باور ستيشن. وهنعمل بعض الفولدز ونشوف how to improve النتورك بطرق بسيطة جدا ممكن انها تتاخد في الاعتبار، والشركات التوزيع تحطها كنقاط لتحديث ورفع كفاءة الشبكة الكهربائية. ايه هي الريلايبيليتي؟ الريلايبيليتي هي ability of the system for adequacy of power، وكمان انها تكون security of power. لما بنحب نتكلم عن الميجرز اللي هي determination of distribution reliability، اللي هي بنعمل gauging measure للconsumer satisfaction، وده بقى فاكتور مهم جدا ابتدى يتاخد في الاعتبار. مش زي زمان كنا مجرد ان انا بوصل كهرباء للكاستمر، لا we have to take into consideration السيستم الكاستمر satisfaction، وكذلك improve السيستم performance basis for network expansion planning, comply with regulatory requirement, we have to take it into consideration, determination performance based rate making. بنحط برضو في اعتباراتنا المينتنس سكادول، لان في المينتنس بتسبب بعض الانقطاعات او بتكون scheduled interruption of power، وده بيؤذي الكاستمر. We will try to elaborate خلال البرزنتيشن how to improve السيستم بتاعنا. من نقاط الكواليتي المهمه ان احنا اصبح عندنا دلوقتي ستاندردز للفولتج والتيار. الفولتج مش بس ان انا اوصل فولتج تيار للكاستمر بتاعي، we have to keep in consideration according to the IEEE ان يكون الفولتج within acceptable limit which is the plus or minus 5%. We have to take into consideration also ان يكون في continuity of power. كذلك بنحط في اعتباراتنا الهارمونكس اللي مع زياده الاجهزه الكهربائيه اللي هي الالكترونيك اكويبمنت و التطور في الصناعه. وجدنا ان هناك كثير من الاجهزه اللي هي زي الفاريبل سبيد درايفز وكل الاجهزه الالكترونيه الجديده اصبحت بتصب في الشبكه هارمونكس كونتنت، والهارمونيك كونتنت اصبحت بتشوه الساينسويدال ويف. بدل ما كان عندنا بيبقى الساينسويدال ويف بصوره كونتينوس زي ما احنا شايفين او اللون البلاك ده، لا اصبحت النهارده مشوهه، وهذا التشوه للساينسويدال ويف الهارمونكس بتسبب كثير من الافكت على الكابلات، على المحولات، تسخين المحولات بصوره عاليه، الكابلات بتسخن، في مشاكل كثيره جدا بتسببها الهارمونكس into the network. طبعا دي اكزامبل للفيفث هارمونيك كونتنت as you can see. كذلك بنحط في اعتباراتنا ان يكون دايما في السبلاي we have to keep in mind ان الفولتج يجب ان يكون symmetrical voltage. في كثير من الاحيان بتجد ان ال 3 phase is not equal، وده طبعا بيسبب لي كثير من المشاكل في الروتيتنج ماشينز وفي الاندستريال نتورك. كذلك الباور فاكتور كوركتور، كان زمان كنا بنحط الباور فاكتور از ان هو اوبشن ان انا احسن الباور فاكتور ولا ما احسنوش، لا النهارده الباور فاكتور بقى يؤثر على الاستابيليتي بتاعه السيستم. كذلك بقى نرجع تاني للجزء المهم جدا وهو الكاستمر ساتسفاكشن از نوت اونلي باي الفولتج، الهارمونكس، الباور فاكتور، بس اولسو الانتربشن اوف باور. الجديد في عالم الكهرباء ان النهارده بقت شركات الكهرباء بتيجي وبتتعاقد مع الكاستمر وتتفق معاه في العقد بتاعها ان انا ممكن اسمح لي اقطع عنك الكهرباء مثلا في خلال السنه ب 10 دقائق او نص ساعه، يبقى الكيلو وات اور بcertain amount of money. إذا كان ما فيش interruption of power أو أقل أو 5 دقائق أو دقيقة أو يبقى في تعاقد على الانتربشن of power. وهنا هنبتدي إن إحنا نشوف إزاي how to avoid الانتربشن وإزاي أقلل مدة الانتربشن of power بالpractical cases with very simple ideas. زي ما بقول الانتربشن it might be scheduled interruption او انها تكون forced interruption. طبعا الscheduled interruption due to any maintenance cases بنيجي نقول والله انا في الفتره دي هعمل maintenance لاحد الخطوط او هعمل maintenance لاحد المحولات او الكابلات regular maintenance not according to short circuit. It's a scheduled maintenance وده بيقطع الكهرباء عن الكاستمر for a certain period of time. الفورسد انتربشن طبعا بيحدث out of your hand لانه due to short circuit او unexpected fault في السيستم، وده بنحاول ان احنا نتجنبه ونتفرج ونشوف مع بعض برضه ازاي نحاول. طبعا بيقسموا الانتربشن الى مومنتري انتربشن او سستيند انتربشن. مومنتري لما هو اقل من 1/5 من المينت بيعتبروا ان هو مومنتري، اكثر من 1/5 من المينت بيعتبروا سستيند انتربشن. ليه؟ لان كل دقيقه او كل ثانيه بينقطع فيها الكهرباء بتجد ان هو بيحصل عندي interruption of power. كل دقيقه بيقطع عنها كهرباء بتوقف برودكشن، بتوقف انتاج، بتؤثر على اقتصاد الدوله نفسها. فالانتربشن ما بقاش ديو تو اني اقدر ان انا اتحمله يعني. الالكتريكال ريلايبيليتي، وعشان كده ابتدوا يعملوا فاكتور جديد اللي هو الريلايبيليتي وياخدوا في اعتباره اللي هو ايه اللي احنا المفروض ان احنا نعمله، ازاي بنقدر ان احنا نقيس البرفورمانس بتاع الريلابيلتي، هناك اندسيز ابتدت انها تتحط وتتوقع، ومن هذه الاندسيز اصبح ان كل شركه توزيع او كل شركه كهرباء at the end of the year بيقدر ان هو يقول والله انا قدرت ان انا احقق عدد من الانقطاعات اقل، عدد من الانقطاعات على الكاستمر بصوره اقل، ويقدر يقول did we do better this year or في ممكن improvement اكثر واكثر، وبناء عليه الاندسيز دي بتتحط في الاعتبار. طبعا بحط في اعتباراتي كثير من النقاط يجب ان تؤخذ في الاعتبار، وهو اذا كان النمبر اوف كاستمرز اللي بيتقطع عنهم الكهرباء، كم كيلو وات انا قطعت عنه كهرباء، لمده قد ايه الزمن بتاع التيار، والفريكونسي اوف انتربشن. مش مثلا انا بقطع الكهرباء لمده من الزمن او بيحصل نتيجه فولت 10 دقائق او 15 دقيقه واقدر ان انا اتجنبها. طبعا دي هي الاندسيز الجديده اللي ابتدى ان هو كل شركات الكهرباء يبتدي يتساءل ما بينهم وبين بعض في فاكتورز اسمه الصيفي. هم اكثر اشهر 4 اندسيز، مش هطول على سيادتكم، هم الصيفي والسايدي والكايدي والكتايدي. ودول هم الصيفي هي عباره عن السيستم افريج انتربشن فريكونسي اندكس، السايدي هي عباره عن السيستم افريج انتربشن ديوريشن اندكس، والكايدي اللي هي الكاستمر افريج انتربشن ديوريشن اندكس، والكاستمر توتال افريج انتربشن ديوريشن اندكس هم الكتايدي. ويوجد فاكتورز اخرى مهمه، ولكن we don't have much time ان احنا نغطيها، ولكن خليني نتفرج نشوف ازاي نقدر ان احنا نحدد هذه النقاط. الصيفي بتتقاس ازاي؟ بتتقاس بفاكتورز ان هو يعرف التوتال نمبر اوف كاستمرز اللي اتقطع عنهم الكهرباء مجموعهم قد ايه بالنسبه للتوتال كاستمر سيرفد. يبقى كل ما بقلل عدد الكاستمر اللي انا قدرت اقطع عنهم الكهرباء، سواء scheduled interruption او forced interruption، يبقى ده بيحسب لي حاجه اسمها الفاكتور اللي هو الصيفي. وفي نهايه السنه كل شركه بتقول انا الصيفي بتاعي في حدود قيمه معينه، ويقدر ان هو يصرف اذا كان مكافآت انسنتيفز للشركات اللي بتبقى الصيفي بالنسبه لها احسن. السايدي وهو التوتال كاستمر انتربشن ديوريشن. يبقى احنا مش بس الانتربشن بيبقى مهم بالنسبه لي ان انا اتجنبه، بشوف العدد الكاستمر، الديوريشن اوف انتربشن، ديوريشن اوف انتربشن بيبقى قد ايه. والسايدي دي از فاكتور بقى النهارده بيطبق في جميع انحاء العالم، توتال كاستمر انتربشن ديوريشن على التوتال نمبر اوف كاستمر سيرفد. انا هحط بعض الجداول يعني بسرعه امشي على الكلام ده لغايه ما ندخل للجزء البراكتيكال اللي ازاي بقى نقلل منه الصيدي والصيفي وكل الاجزاء. الكايدي هي التوتال نمبر كاستمر انتربشن ديوريشن على التوتال نمبر اوف كاستمر انتربشن. اخر حاجه هتكلم عليها هي الاسايدي اللي هي الاندكس اوف ريلايبيليتي اللي هي الافريج سيستم افيلابيلتي اندكس، ودي بتساوي الكاستمر اورز اوف افيلابل سيرفيس على الكاستمر اورز سيرفيس ديماند. وده هي القوانين اللي احنا بنشتغل بيها. لان كل دقيقه زي ما قلت ان في كوست اوف انتربشن. الكوست اوف انتربشن لها جداول، بيوجد جدول بيقول لي قد ايه الكوست اوف انتربشن. كوست اوف انتربشن نوت اونلي فور ذا كاستمر، لانه هو واحد عنده مصنع وبيشتغل عليه وبيجد ان هو انقطعت عنه الكهرباء، توقف المصنع، توقف الانتاج، عجله الانتاج، عجله الاقتصاد توقفت بالنسبه للكاستمر وبالنسبه للدوله. كذلك بالنسبه لليوتيليتي there is a cost of interruption. طبعا يوجد كثير من الشرح على بالنسبه للكوست اوف انتربشن في الاندستريال قد ايه، والكوميرشال قد ايه، والريزيدنشال والجفرمنتال والاوفيس بيلدينجز. الانتربشن لو اتقطعت لمده دقيقه بتكلف قد ايه الدوله؟ ب 20 دقيقه، ساعه، 4 ساعات، 8 ساعات، لان في بعض الاحيان في الانتربشن اوف باور على الاوفر هيد ترانسميشن لاين it might reach up to 6 to 8 hours او اكثر كمان. فليها كوست. طبعا حسابات كثيره مش عايز اخش فيها، لكن انا مهم جدا ان انا اعرف ازاي بقى هنا بعد ما عرضت الكلام اللي هم الايكويشنز اللي بيحسب بيها كل شركه الصيدي والكريدي والصيفي، ومنها بيقدر يحسب الريدكشن بقى. ايه الاكشن اللي انا لازم اعمله؟ هو ده الاوبجكتيف اوف ذس بيبر تو بريزنت. الريدكشن اوف نمبر اوف فولتس، ازاي اقلل النمبر اوف فولتس، ازاي ريدكشن اوف تايم انتربشن، تايم اوف انتربشن اقلله، reduction of number of affected customers، عدد الكاستمرز اللي affected we have to take into consideration. These are 3 points لو انا احطهم في الاعتباري هحسن بيهم الصيدي والكايدي والصيفي. طبعا امور كثيره جدا ممكن most important measures for reducing the fault rate. البريفنتيف مينتنس اهتمامنا بيه بيقلل اللي هو السكادول مينتنس والفورس مينتنس. نقاط كثيره جدا، ولكن لضيق الوقت اسمحوا لي ان احنا نجري علشان نوصل للاكشن اللي احنا هنعمله عشان اقدر ان انا احقق الامبروفمنت. ازاي احقق الامبروفمنت دي؟ باني اعمل فيدر اوتوميشن. في حاجه اسمها فولت باسج انديكيتورز، دي هنستعملها ونتفرج عليها ازاي بنطبقها. ريموت مونيتورنج والريموت كنترول اند سكشنالايز. فيري سمبل ايديا ان انا عندي بيبقى الترانسفورمر بيطلع على بيلر، كل بيلر بيغذي كل الكاستمرز المختلفه، ولكن انا لو حطيت في اعتباراتي في نهايه كل نقطه، في نهايه كل بيلر، لو اقدر ان انا اربطه بتاي ان ما بين التو ترانسفورمر، بتاي ان ترانسفورمر مجرد كابل واحد بس، لو امده ما بين نهايات الراديال سيستم، بتبص تلاقي ان انا لو حصل فيلير في الترانسفورمر ده انا ممكن immediately انقل الباور على الترانسفورمر الاخر واستمر في تغذيه الكاستمر بتاعي. هنا هبتدي بقى اللي هو الجزء الاخر من الفيديو اللي هو او الانيميشن اللي هتوريني ازاي بقى ان انا اقدر ان انا احقق السيستم. السيستم ده عندي على هاي فولتج سبستيشن بتتغذى بالمفتاح ده اهو، وبتغذي المدينه بالكامل. الانيميشن بقى لو سمحت. هنا بنجد ان انا عندي في السيستم، بليز كليك على الستاندرد اندر جراوند، ادي البرودكشن في المدينه ده اهي. بجد ان انا لو حصل عندي فيلير بهذا الشكل المفتاح بيفصل. ايه الطبيعي اللي احنا كنا بنعمله زمان؟ تبعت من الكنترول سنتر عربيه تقف عند اول ميديوم فولتج تنشن وتفصله وتقول له والله جرب، يقفل السكينه تحت هنا اهو في الهاي فولتج، بص تلاقي بيضرب تاني، يقفل وياخد وقت ان هو بيمشي في المرور، بيمر الزمن، بيمر في المرور، بيقف على كل محطه يفتحها وياخد وقت. This is a very long time للنمبر اوف كاستمرز اللي موجودين اتقطع عنهم الكهرباء، بيحصل loss اوف باور، وده بيحصل عندي ستريسز عاليه جدا. وعشان كده انا بحاول ان انا نشوف ايه الجديد في عالم الكهرباء. 5 minutes yes okay. keep going please. فنشوف لو انا بعمل كليك على الستاندرد اندر جراوند نتورك لو سمحت، يكليك على ايوه. بنشوف ازاي بنحسن الصيدي اللي هو سيستم افريج انتربشن ديوريشن تايم. ببساطه جدا بيحط انديكيتور اللي هو الفولت انديكيتور، عباره عن انه بيبقى ليد لايت بيوريني الفولت، المسار لو مشي فيها فولت في السيستم، لو مشي في المسار ده فولت في اني شورت سيركت بيوريني الشورت سيركت. يعني لو الشورت سيركت حصل في النقطه دي بتبص تلاقي كل المسارات اللي حصل عندها الشورت سيركت بتنور، بتديني ليد انديكيتور لهذا. فدي مجرد انها ليد في كل ميديوم فولتج. بص العربيه بتاعه الاوبريتور خلاص ماشيه، وهو ماشي شايف الليد، عارف ان المسار بتاع الكابل اول ما يلاقي لاست فلاشنج والنكست نون فلاشنج يعرف ان الفولت ان بتوين ذيس تو بوينتس، فبيفصل السكينه للمحطه دي وبيرجع يفصل السكينه ان نو تايم بص تلاقي يبقى انا هنا قللت عدد، وفي ثانيه اول ما هيفصلها هيتصل بالكنترول سنتر يقول له يقفل المحطه تماما، يقفل الخط، وبكده يغذي الشبكه. يبقى الفولت ديوريشن تايم قل، وكمان النمبر اوف كاستمرز اللي هم كان مقطوع عنهم الكهرباء لمده طويله، ويبقى هنا قدر ان هو يوصل الكهرباء ويقفل اخر التاي اب اللي موجود عندي في السيستم. وده طريقه لتقليل اللي هم الزمن. والصيدي ممكن برضو ان انا احسنه بانه بيزود في السيستم بتاعي حاجه اسمها المونيتور، اللي هي اندرجراوند نتورك ريموت مونيتور، في نقطتين علشان المونيتور دول يكنترول او يقدروا ان هو يكوميونيكيت مع السيستم لو حصل شورت سيركت. نفس الاكشن، ولكن الريموت مونيتورنج بيبعت للكنترول سنتر وبيقول له ان الليمب او الفرع اللي حصل عندي الشورت سيركت فيه هو الفرع ده اهو. يبقى العربيه على طول بتتوجه immediately، لانه اول ما بيلاقي الفلاشنج والنون فلاشنج يعرف ان الان بتوين هو الفولت، وبيعزله تماما ويقدر يفصل الوقت. وهنا بيخلي الكاستمر يتوجه الى النقطه تماما. هيفصل immediately، شوف الوقت قد ايه اللي قل عشان يخلي الكنترول سنتر يقفل السكينه العموميه، وبذلك يقدر ان هو يوصل الكهرباء immediately لكل الكاستمرز اللي عنده. اخر حاجه هنتكلم عليها وهي اضافه ريموت كنترول او اوتو ريكلوجر في بعض النقاط في السيستم، هتخلي لي الانتربشن تايم اقل، وهتخلي لي النمبر اوف كاستمرز اللي افكتد بالفولت اقل بكثير جدا. اخر حاجه اللي هي بيبقى الاوبريشن، ان انا هستخدم الاوتو ريكلوجر، او اللي هو اخر حاجه بيحط اوتو ريكلوجر في بعض الاماكن، بيختار اماكن محدده. ادي في حوالي 4 اماكن اقدر ان انا استخدم. تعال نشوف بقى لو حصل نفس الفولت، شوف الاكشن بيفصل السكينه العموميه immediately، بيبقى الفولت معروف مكانه فين. الريموت كنترول بيقدر من اوتو ريكلوجر ان هو يفصل السكينه من الكنترول سنتر، وبكده يقدر ان هو يقدر immediately يوصل الكهرباء من الكاستمر. فتجد ان من المين اوفر هيد هاي فولتج سبستيشن، تلاقي ان الديوريشن قبل ما ينزل الاوبريتور بتاعه قفل الاوتو ريكلوجر، تغذيه تمت للكاستمر من فوق، ومن هنا مجرد ان هو يفصل السكينه يقدر يغذي بقيه الكاستمرز في الجزء الاخر من الشبكه. وبكده يبقى هو قلل النمبر اوف كاستمرز، قلل التايم اوف انتربشن، وبكده حسن السايفي وحسن سكايدي بمجرد نقاط بسيطه جدا، سواء اوتو ريكلوجر او مجرد ليد للسيستم. وانا عشان الوقت اشكركم لحسن استماعكم، واشكر سيادتك على سعه صدرك. شكرا.
شكرا Professor Salim. It was an excellent presentation, and we said that inshallah all questions will be asked at the end of all the sessions. And we were requested also to all the presentation will be in English, and they forced me to speak in English. So we will proceed with our second presentation. The presentation is called Intelligent Compact Substation for a Smarter Grid. It will be presented by Bernd Sugarflame, and he's an engineer working as a key expert control technology in medium voltage switchgear for energy management division in Siemens. He completed professional education at the Siemens Technical Academy as an associate engineer. He has many years of experience in the engineering and configuration of medium voltage switchgear. For about the last 5 years, he has attended to the matter of intelligent transformer substation as an integral part of the future smart grid, and coordinating the market requirement with the switchgear development required for this purpose. So please proceed, you have 20 minutes.
Thank you very much, Mr. Chairman. Good morning, gentlemen. I would like to start my presentation which is called Intelligent Compact Substation for a Smarter Grid, with two main drivers for this topic, why everybody in the world is discussing at the moment about this topic. I have here a picture where we can see on the left side the classical, the traditional grid structure. What means we have on the one hand side the big power plants which supplies energy, and on the other hand side we have the consumers, and from the generation to the consumers we have one-way direction, so an unidirectional power flow, which is very easy to handle in most of the situations. When we compare it on the right side with the future grid structure, which by the way is already standard in Germany in some cases already due to a lot of renewable power generation we have there, we see there that we have not only one clear unidirectional power flow, we have there a big mesh system where we have power supply in all voltage levels. That means in the low voltage level, in the medium voltage, and also in the high voltage level we have power generation. And all of these power generation, what could be also wind turbines, what could be distributed photovoltaics on rooftops of houses, etc., makes the handling of our grids a little bit more complicated than it was in the past. And this is really one of the main drivers why everybody now thinks about how to install possibilities to measure voltage, current, to communicate from transformer substation to the control center, to handle these situations which can be caused by the distributed renewable power supplies. The second thing is what you have also to think about when you have these distributed power supplies, and you would like to supply into, for example, the low voltage or the medium voltage grid, then you have to increase the voltage to be able to put the power into the grid. But on the other hand side, we have a standard which is called EN 50160, which allows you only to increase the voltage about 10% of the nominal voltage. What means you have on the one hand side to measure if you have a voltage problem, and if you reach this problem, you have to act on it, to react on it. So therefore, you need to have some further information in the grid which you haven't had already in the past. And the second driver we have already seen in the presentation of the professor is that the fault and outage management, the classical one we have today, it's a long way management. That means you have to drive in some cases from substation to substation to find out where the failure has been. Then you have to call the control center, then they have to make some switching. So a very long procedure, and dependent on the grid-free calculation. And by the way, there are several countries already who have a grid-free calculation, what means every failure which is beyond 3 minutes was not a failure, and if you have failures which are over 3 minutes outage time, then the operator has to pay real penalties for the outage times. So therefore, a lot of operators already think about how to automize their grids to be able to bring all the failures which can be caused to different situations under these 3 minutes barriers. And with a classical way to drive from substation to substation, it's not possible. Yeah, but the problem on the other hand side is when we are thinking about to bring automation into our grids, and when we have a look here on this, where we see the complete power flow from generation from the big power plants to the consumers in the low voltage grid at the end, we have automized, or we have information sensors everywhere in the big power plants, even in the transmission area. But the more and more we come in the distribution area, and at the least to the low voltage distribution grid, we don't have any information about voltage, currents and whatever. So it's a kind of cloud. And now in this area we need this information to be able to react on all the problems which are caused there. So therefore a big topic will also be a retrofit of existing substations. We as supplier, I'm from Siemens, we would like to sell you complete new substations, that's clear. But on the other hand side, if your substation is almost 5 years in use, you will think about how to retrofit them, and therefore we have also to think about to find a real good solution for retrofitting existing substations. Yeah, but when we are talking about intelligence in the distribution grids, several times there come up discussions, what is the understanding or the meaning of intelligence? And therefore we have tried to make a clear definition. We have defined the 3 levels of intelligence. So the first level is a poor monitoring, what means you have information from the substation, but you are not able from remote to control them. An example could be you have a short circuit earth fault indicator with a remote signaling contact, and therefore you are able, in case of a failure, to send directly somebody to the affected substation and not to send somebody to drive from substation to see where the failure is caused. So that brings you in the position to have a faster fault location. The second level of intelligence is a telecontrol, what means you have next to the poor monitoring also the possibility to react on these. That means via remote control. So we have motorized breakers in the substations, what minimize the outage times from hours to minutes. And the third level would be the highest level, it's a power flow control, and within this level you are able, for example, with distributed on-load tap changing transformers to react directly in the grid with components in the grid on voltage problems. So these are the 3 levels. And coming to an example for a ringmain unit, what we developed in the last few years to bring our ringmain unit into the position to be fit or to be ready for these smart grid requirements. I have here an example. One most important key component inside the ringmain unit would be an RTU. An RTU which is a master in the substation and which makes a communication to the control center and collects all information in the substation. This communication can be done via different protocols. There could be, for example, IEC 61850 or even 101 or 104 protocol. Next to this RTU, intelligent devices are also required as short circuit earth fault indicators. So we as Siemens, we have also developed an own one, which has a clear interface from the electronic device to the sensors which are installed in the cable compartment and measure their voltage and current. By the way, we are using low power voltage and current sensors there due to the newest IEC standard. And the big advantage of these sensors is they are easy to install and they are not as big that we have to increase the width of the panels, so we can install them in existing panels, in the existing dimension of the panels. And there's a clear interface between the sensors, IEC standardized interface between the sensor and the electronic device. In case of an error, of a failure of either the device or the sensors, you are able to change only one of these components and not the complete system. And then we have also developed a motor control unit with a Modbus interface. So that means you are able from the RTU to this Modbus MCU motor control unit to communicate and then directly control the motor, and you receive then back via Modbus also the information if the auxiliary switch is in on or off position. So this is a concept for an automized ringmain unit for the future smart grid. And next to, as I also explained, it could be that in some cases is it necessary due to voltage problems to install also an on-load tap changing transformer in the distribution grid. Also therefore we have developed a solution which is very compact, so the dimension of these on-load regulating distribution transformers are almost the same like the classical ones. And with this transformer which has no moving part inside the vessel, so everything will be done outside via additional tappings. And there we are able to react on voltage increases, or even if you have a voltage decrease due to a lot of load. Therefore, you can react with this transformer also to these situations. The communication concept is also a very important thing, because if you think about to retrofit or to use new substations, you don't want to have a lot of wiring, and therefore we have a system which is based on a Modbus communication. That means all the devices which are connected to the whole system communicate via Modbus RTU, which makes it very easy, because Modbus RTU you need only 2 wires and that's it. So therefore all the components, which could be on the one hand side the RTU, the short circuit earth fault indicator, the motor control unit, transformers, and also power quality devices, or even if you think in future that in substation could also be motorized low voltage circuit breakers, then all of them can communicate together via Modbus RTU, and then from the master, from the RTU, the communication to the control center will be done either via 104 or 61850 communication. And with this concept, where we have seen the communication concept inside the substation is based on Modbus RTU, I have now an example also for a fault and outage management with a communication to the control center on the one hand side with 61850. This is a traditional grid where we have 2 rings connected together, and in case if a failure occurs now in one part of the grid on the cable, then the part which is powered from the right, the big transformer which you can see on the right hand side on the top, is out, so there's there's an outage in this area of the grid, and then all the devices in the substation, the RTUs, are connected together via ISE 61850. They communicate together without any master in the control center. They decide, okay, the failure was between these 2 substations. They open the breakers in these substations. Then you can immediately, if the failure is isolated, you can power again the right side of the grid, and then also via closing on the left hand side on the top the breaker, you can power also the complete grid again. And if you have a look on this time, what is on the right, on the watch which is on the right side, the outage time was less than 1 minute. So a very fast fault and outage management with ISE 61850. If we have a look on how this works with 101 or 104 protocol, it's more or less in the same way. The only difference is you need somewhere a kind of regional controller which can be installed in a primary substation, and then the communication is not from the substation to the substation, so every communication will be done to this regional controller, and from this regional controller then also the remote control commands come to the substation to open and isolate the failure. And then it's the same way, also within less than 1 minute, the whole grid is powered again. So these are 2 examples about the benefits which can be, or which can you have via installing intelligent transformer substations into the grid. At the end of my presentation I have 2 references with me. There are different constellations of these compact substations. The one could be that everything should be integrated in the ringman unit, what means even we put on the top of the ringman unit a special low voltage box where we install all the components, or even you can install them directly in the drive compartments of the switchgear. And the second solution will be a solution which is also optimized for retrofit. That means a separate distribution automation box which can be installed somewhere outside or inside the substation and plug and play connected to the switchgear, which also at the end of the lifetime of such a box with a lot of electronic device, because this is also a topic where you have to think about. And the expected lifetime of a ring main unit of a transformer is around 30-35 years or even more. And if you think about the expected lifetime of electronic parts, then you will see the expected lifetime is around 10-15 years almost. So therefore, in one cycle lifetime primary part, switchgear and transformer, you have to think about to change the electronic part. And therefore, this plug-and-play connection is a very easy possibility in case of end of lifetime of the electronic part to go there with a new distribution automation box, connect it again, and within minutes you can continue your grid operation. So that was my presentation. Thank you very much for your attention.
Thank you, Bernd, for an excellent presentation and also maintaining the time. Third presentation here is called Smart Power Generation, SPG. This presentation will be delivered by engineer Sami Al-Harbi. He's a general manager of business development for Tesla Energy Solution in Saudi Arabia. Sami holds a bachelor degree in mechanical and master industrial. He started his career with the Saudi Electric Company for 10 years till he became the head of mechanical and civil engineering division in regional headquarters. He worked in Aqua Power as an executive manager in asset department before he joined Wärtsilä. Sami, you have 20 minutes. Go ahead, please.
Thank you very much, Chairman. Assalamu alaikum wa rahmatullahi wa barakatuh. Sabah khair alaikum jami'an. Very good morning indeed, gentlemen, and really appreciate this valuable opportunity to be here and just to shed the light on the smart power generation that is a new, I would say, concept, specifically what we would like to promote here in Saudi Arabia. So just to start the presentation, to see what it's the contents of the presentation itself. First, we would like to just very quickly see what are the challenges that we have in the power system of Saudi Arabia. And from there, I'm going to take it as an entrance for the smart power generation and why do we see smart power generation a valuable concept that could enhance the efficiency of the power system in our country. And from there, of course, to just get some feelings, we will go and see what will be the differences if we adopt such concept in a real case that's happening not far from Saudi Arabia. And then also what will be the benefits if we join actually between the renewable energies and the smart power generation as a concept, and by the end to see the reflections of what we are trying to promote as a concept. So if we think about the challenges in the power system here in Saudi Arabia, of course, I would say the whole country right now is driven towards more efficient utilizing the precious resources that we have, of course, as an oil. And that would be actually something to implement it in the whole chain, I would say, starting from the power generation side itself, going through the transmission and ending up at the consumer side. So the whole chain actually, I would say it's required than any more or before in order to have lean process, more efficient, which is actually, of course, in the favorite side of everyone involved in this, I would say, industry or sector. So the challenges we have, if we consider the fleet, which is in the generation side, of course, that we have old fleet still running in our power system. And we do know that there are retirement plans, but the growth which exert major force, I would say, in the generation side, forces us to keep those units running especially if we consider the peaking operation in the summer season. Also, I would say the variation in the load profile, if we consider the load profile at any region of our interconnected grid, we will see a huge variation that needs to be taken care of, which right technology that we need to deploy in order to overcome this challenge. And from there also, one important factor, I would say, or direction in the electricity market, of course, the fuel allocation. The uncertainty in this factor is very huge. From experience, what we have seen, we cannot have a plan, let's say, of what are the type of fuel and the quantity we can, for example, or it's going to be available for the coming 5 years or 10 years. So this uncertainty, of course, would have an impact on how to move, what are the technologies that we'd like to consider in our capacity addition for the future projects. So, but if we take it from the positive side, then what would be the opportunities that we might think of in order to overcome those challenges? Of course, we need a technology that would provide us with a fuel flexibility in order to hedge, I would say, this uncertainty and overcome it. Also, the variation in the system itself can be also mitigated, I would say, with a technology that would not have an impact from the cycling or the peaking operation. So this actually would introduce for us the smart power generation. What is the smart power generation? It's, as you can see from this triangle, we have three cornerstones, main cornerstones, I would say, starting by the energy efficiency. We need a unit to be deployed that can be considered as high efficient compared to other technologies in order, of course, to have more efficient operations. Also, the operational flexibility. We need flexible unit in dispatching the load and to become responsive to the variation in the system itself. And also the third cornerstone is the fuel flexibility. We have fuel allocation. We might think of the gas fuel, which is the natural gas available in the kingdom itself. If we go for the liquid fuel, then we will have a wide range of liquid fuel, starting by the crude oil itself, then the HFO, the ASL, AXL. So this uncertainty, I would say, if we can have a technology that provide or can burn different type of fuel, then it would be a fit solution to mitigate this risk. And of course, this smart power generation is the leading factor, I would say, to a smart power system, which can be affordable and also reliable at the same time. So if we consider a load profile, and this is actually something we can say as a demo, it's not actual. And what are those values we are talking about here involved in the smart power generation? So if we start at the phase one, when we have the startup of the unit, the features given by the reciprocating engines, that it can be synchronized to the grid in less than 1 minute. And this fast response actually can give you an advantage in order to mitigate whatever changes or variation, and also would reduce the spinning reserve required in the system itself. And we know how much cost could generate this spinning reserve. And from there, if we move just to have a stable load, then of course those reciprocating engines varies in their efficiency, starting from 42% up to 47%, depending on what type of fuel you are burning in here. And if you go to the point number 3, where this is, I would say, the actual thing happening. We cannot assume that we have a flat load running, and accordingly we are evaluating the technologies. It would not be, I would say, the perfect or the most accurate feasibility or judgment from our side, unless we consider that the power system in Saudi Arabia or wherever is a dynamic that is subject to spikes going up and down, and anything, if we say it rather than this one, I would say that it's a hypothesis. It's not reflecting what we have as a reality. So in that variations, if you have a unit that would not be affected from lowering its capacity, then it's an adding value, of course, to the system and the overall efficiency of the system itself. And if we go also till the shutdown or loading those units at 25% or 30%, then the degradation that we experience in other technologies would not be here. So this is another advantage why we are seeing a very high potential utilizing this technology in our power system. So just to get feeling what we are talking about, here is a real case actually, and this is our IPP or plant, Warsila plant that has been deployed in Jordan. The total of the two plants was around 850 megawatt, and you can see actually the load profile. Before the deployment of the smart power generation or the reciprocating engines, you can see how are those spikes happening actually at the first top graph. And after deploying those engines, then you can see at the orange color how those engines take up or shave those spikes or variation, and let the other technology like the steam and combined cycle to run at their optimum state, where they are fit to be as a base load technologies. So this would actually shave the cost you are experiencing from having this variation, plus also utilizing the other technology, as we say, the combined cycle and the steam units to run at their maximum efficiency, we would say. So the last topic before the reflection, I would say, is how do we see those engines? We tried actually to build a model utilizing the engines, the reciprocating engines with the solar PV. We are seeing a lot of synergy, I would say, because of the feature of the smart power generation. Intermittency in the renewable resources is very high, and accordingly you need the technology that would very fast cope up any shortfall could happen in your generation side at solar plant or a wind turbines. So to complement, or we can say that it will be working as enabler for those renewable energy to become more reliable, and also would mitigate any hassle that you could have while connecting those renewable resources to the power system by having a consistent dispatching or power generation from those engines. So what are the main features we can gain actually from this combination between the reciprocating engines and the solar PV? We could reach to a plant of 49% as efficiency at any loading factor, and of course this would give us a huge saving in our precious resource, which is the oil, and could save from the quantity or the consumption around up to 17%, and that is actually equivalent to 31 gigawatt hour per year. And also another important factor, that you have a greener site, I would say, which will reduce the emission from the plant itself. So this is the synergy or the harmony that we are reading from having the reciprocating engines beside the solar PV. And finally, I would just recap or give highlights about what are the opportunities that we can see in the power system of Saudi Arabia utilizing the concept of smart power generation. Of course, it's gonna give us more efficient power system utilizing the right technology for the right segment of the load profile. Because whenever we think about the load profile, as we stated earlier, that it's not flat, it's a dynamic thing, and we have to react with it accordingly. So we define in each segment what type of technology we need. We are not saying here that we are going actually for all the capacity addition in the future to have it from reciprocating engines, no. But at least once we have this variation or peaking application, then we would put the right technology in order to cover that load or that segment. And of course, as we have seen, what are the advantages that we might have if we combine the solar power plant with those reciprocating engines, and what are the benefits from there. And finally, also, not to forget, again, the uncertainty in the fuel allocation. As we have stated, we have seen several projects, several changes at, I would say, to the last minute in their fuel allocation, and that would say that it's a risk. So if we have a technology that can provide you with dual fuel or tri-fuel, then it's going to be very supporting in order to mitigate or hedge those risks. And what we have seen as that plant, actually, it's a world record as the biggest reciprocating engines plant, and the capacity, as it's mentioned here, 573. And this is actually a conclusion for my presentation, and thank you very much for the time.
Thank you, Jerry Sami, for an excellent presentation, also keeping up the time. Finally, last but not least, we have the presentation called the Economic Operation of the Power System. This will be presented by Engineer Ihab Al-Jadaybi. He's the Manager of Economic Power Division for Saudi Electric Company. Graduated as an electrical engineer from the Arab Academy for Science Technology in Alexandria. He has a master's degree in electrical engineering from King Abdulaziz University. He has worked for Saudi Electric Company since 2002. Ihab, تفضل.
بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. شكرا سعادة الرئيس. My presentation is about the economic operation of the power system, particularly the system of the interconnected system of the Kingdom of Saudi Arabia, the National Grid Saudi Arabia. We will talk about some economic operation KPIs, and we will go through the company efforts to improve the economic operation factors and the challenges the system operator face and the company as all to meet the big demand and the load over there. Before starting the presentation, I would like to show some typical load profiles during the year, and this load profile will show how is the challenges of meeting the hourly load and maintain the system economic operation by meeting this demand. So as we can see, the highlighter is not working, sorry, but as we can see, for example, in the summer profile, how is the difference between the minimum load at 7 o'clock in the morning and the peak load at 15 hours, which is the load increases by about 10 gigawatt. Actually, 10 gigawatt is more than the peak load of any other GCC system. So, meeting this 10 gigawatt every day by starting up these units on daily basis, while all in the same time
maintaining the economic operation and the efficiency, high efficiency requirement, which is a really great challenge. Also, we can see that the load profile is different between the summer and the winter. It is affected by the social activities, by prayer times, by schools start, by because most 50% of the kingdom load is residential load. So all the social activities are reflected on the load profile, as we can see. In the second slide, we can see also the annual growth of the peak demand and the energy demand in yearly basis. We can see in the average growth rate in the period from 2013 to 2019 is about 7.6%. Last year we achieved 62.5 gigawatt peak demand. And in the energy annual growth, it is about 7% as well. In 2015, we achieved about 350 terawatt hour of energy load. So this annual growth is extremely high if we compare it to the other systems in the matured economic countries. So it also reflects the company challenge to meet these annual growth by putting too much investment, which are, as we know, the big load becoming the summer, which also not, it doesn't have the economic visibility as the load in the winter is almost less than 50% of the load of the summer. So most of these capacity are not well utilized. This is the factors achieved in 2014 as 2015 data not yet audited. So for the generated energy, the company achieved 69% or almost 70% by its own power plants, and the rest of the energy generated by the company partners like the IBB and the IWB and the other big producers. The achieved efficiency was 34% in 2013. The average fuel the average fuel consumption was 1.9 barrel per megawatt hour. The daily consumption of fuel is about 1.1 million barrel, equivalent barrel actually. In 2015, we have achieved improvement of about 1% in the efficiency, so it is about 35%. Also for the fuel combination, as you know, the fuel consumption is another challenge in the kingdom, as almost all the generation fleet is conventional generation, which depend on the fuel consumption. So we try to improve the efficiency and minimize the fuel consumption by improve the technology used in the generation. As we can see, this slide compares between 2010 and 2014. In 2014, we increased the percentage of the steam turbine generation by 2%, almost from 42% to 44%, and the simple cycle reduced from 50% to 38%, which also improved the system efficiency. We will see this in the next slide. The combined cycle improved from 8% to 18%. This slide shows the improvement in the system efficiency year by year from 2009. We can see in 2009 the efficiency was about 31.5%. Now it is 34% by continuous improvement during the last 5 years. Also, the average fuel consumption reduced from 2 barrel per megawatt to 1.9 barrel per megawatt. This year, 2015, we achieved about 1.85 barrel per megawatt, so the improvement is still going on. Actually, this slide shows the fuel mix allocation. In 2010, we were using 40% of the system generation was depend on the crude oil. Now, this 2014, the crude was participated by only 35%, so that we are reducing the fuel dependency on the crude. The gas consumption is increased from 33% to 35%. The diesel also reduced from 22 to 20%. The heavy fuel from 5 increased to 10. Actually, this meets the national economy requirements, which is to maximize the gas consumption and minimize the diesel and the crude consumption. How all these efforts achieved? This by major efforts to improve the fuel optimization and the improvement in the efficiency in the system. This happened in all sectors in the company. In the generation side, all the generation expansion projects specified to operate at maximum efficiency. This by the system operation to make sure that to increase the efficiency in the operation to the will use of the current assets. The simple cycle power plants, most of them are now converting to a combined cycle generation. All the new power plants now achieve the maximum efficiency. We are now having power plants operated at 56% almost of the efficiency, which is the one of the highest efficiency power plant in the world. Also, now the participation of the renewable energy. Now the company have pilot projects in different places by about 320 megawatt of pure renewable energy, in addition to the project which has about 10% of the renewable energy. Also, in the network side, now the network are enhanced by releasing the congestion point, which is force the operator to run an efficient generation to meet, or let's say less efficient generation to meet the system congestion and open the bottlenecks. Now the network are enhanced to release these bottlenecks. Also to enhance the interconnection between the neighbor companies like the GCC interconnection and the Egypt interconnection to encourage the power trading between these countries, which reflected also in the efficiency improvement in all the region. This shows the system, the grid system in the kingdom, the current and the future. The interconnection between central region and southern region will be also enhanced by another new circuit, the DC, high voltage DC link between the central and the western region. All these are future projects, the interconnection with Egypt. So this also will help improving the efficiency more and more in the future. This slide shows the main or major projects. Now some of them already done and some of them in the progress, and some also in the future will be executed. The major projects which has been already achieved, the gray combined cycle, which about 3,500 megawatt. This power plant runs actually at 56%, which is the most efficient power plant in the kingdom, along with BB12 in the central region with about 2,000 megawatt. Also the renewable energy projects, we have some pilot projects in some isolated areas or remote areas with photovoltaic cells or wind turbine in Aqaba area. This slide shows how the future look like. As I said now, currently we are the gas contribution is now 35% in 2014. In 2024, about 9 years later, it will be 75%. This is the vision. The diesel almost will be eliminated by 10 years from now or 8 years. The crude will be reduced from 35% to 10%. The HFO will be about 13%, as most of the generation will be generated by the gas fuel. The efficiency, currently it is 34%. In 2024 it will be 47%. The fuel consumption from 1.9 barrel per megawatt hour, it will be 1.4 barrel. This is what we think we are going, and we will be sure. This is my presentation, and thank you for your audience.
Thank you, Engineer Ihab. By this time, we, alhamdulillah, conclude our first session, but if you allow me just to go briefly on all the presentation, just give you a brief on just a minor brief on the topics of these presentations. The first one was done by Professor Salim Khudari. Mainly was talking about the reliability, and he also talked about the interruptions and the customer satisfactions. He also was mentioning that the interruptions actually in two sides, whether it's a scheduled interruption or a forced interruption. Mentioned about the harmonics and the effect of harmonics on the sinusoidal wave, and mentioned also the remote monitoring and the sectionalizing of the distribution network. Also talked about the fast response and also the auto reclosers of the in case if you have a fault on some of the feeders. And Bert also was talking about the intelligent compact substation, the outage management, and was talking about the retrofitting of the substations, and mentioned about how the RTUs can remotely monitor your network. Sami also was mentioning about the major challenges that faces the major electric company, about the low efficient retirement units, how these can be enhanced, and talked about the load variations, the fuel, and the benefits of adding some of what he mentioned, that the efficiency could increase to 49%, and the saving in the fuel will be about 17%, almost 31 gigawatt hour per year. And of course, one of the major things that we are all actually monitoring now is the SACs and NACs and the reduction of this. It's a very important topic. Last but not least, Ihab talked about a subject is very dear to myself actually, is the peak demand, or how we shape the demand, and the summer loading, the winter loading. Mentioned about the efficiency of last year, 2014, is about 34%, or this year, 2015, and the trend to go on the percentage of utilization of the steam units, the combined cycle, and the simple cycle. The combined cycle mentioned that it will increase. This is actually the major impact on all our system actually, is that it will increase from 8% to 18%. That's a major jump actually, and this coupled with the reduction of the simple cycle from 50% to 38%. And of course, the fuel that will be burned per megawatt hour, mentioned that it's about, this year is almost 1.85 barrel per megawatt hour. That's an excellent achievement. I think with the cost now of the fuel, the trend will be actually to minimize the liquid fuel burning, inshallah, for 2016 and the years ahead. So I really appreciate all the time that was done from our guys. Now, I think we have a couple minutes here to have any question, if somebody from the audience has a question. Yes, please, go ahead. Please identify your name first, and say the question to which gentleman, okay?
Yeah, my name is Shukura. I'm from Shirkut. question goes to Dr. Sali and Ms. Sali. Regarding the role of energy conservation in system reliability in smart grids, because I have not, I missed or something again. And other question goes to Engineer regarding the any live wind turbine in Saudi Arabia, where it is and what is the capacity? Just wondering about it.
Okay, thank you for the question. Actually, when we said that the combination in the hybrid solution, which we are seeing, combining the reciprocating engines and the solar PV, this is an exercise which we had done and investigated thoroughly with our partner First Solar. So what we are seeing as advantages or features that is inherent in the reciprocating engines because of the fast response. So, and the intermittency coming from the renewable resources. Once the sun is not there actually, or the weather is cloudy, then you will have a shortfall or drop in your production. So you need a technology that is reacting very fast in order to cope up this drop and deliver the power needed. So this is the harmony which we are seeing between the reciprocating engines and solar PV.
Regarding your questions about the wind turbines, currently I don't know there is a wind turbine connected to the system, but there is a potential project of 100 megawatt I have mentioned in my presentation in Aqaba area. This is still a potential project under study, not open for bidding yet.
Thank you. Any other question? We'll have somebody in the middle here. Mic, please.
السلام عليكم.
عليكم السلام.
جمال برنامج تدريب التنويم. أنا عايز أسأل بس بروفيسور سالم عن الريلابيلتي. طبعا عرض جيد، لكن في البداية حضرتك أشرت إلى تأثير الهارمونكس على السيستم ريلابيلتي، برغم إن فيه بعض الأيتمز الأخرى مؤثرة جدا في الريلابيلتي زي الساجز والسوالز والكليبر والترانزيان، ودي كلها بتأثر في السيستم ريلابيلتي بس ما تمش الإشارة إليها. النقطة الثانية بالنسبة للريكلوزر، احنا عندنا في الجنوبية لما بنركب مثلا أكثر من 2 ريكلوزر بيبقى فيه صعوبة كبيرة جدا في عملية الضبط بالريدويشن بين الريكلوزر وبعضها، وإلا بيحصل كل مشاكلها أكثر من تركيبها. فاحنا لحد 2 السيتنج بيتعمل كويس وما بيكونش فيه مشاكل، أكثر من 2 بيبقى فيه مشاكل. النقطة الأخيرة بالنسبة للصيدي والصيفي والقيدي، هل فيه ستاندرد يقول ان انا المؤشرات بتاعتي جيده ولا لا، ولا الشركه المفروض تقارن نفسها بنفسها وتحسن في الريلابيلتي، ولا في مقارنه بين الشركات عشان نعرف احنا فين بالظبط؟ شكرا جزيلا.
عربي، الرد عربي ولا انجليزي؟
هو سأل بالعربي، رد عليه بالعربي.
الحقيقه هو السؤال اكثر من يعني 3 اسئله مع بعض. بالنسبه اللي حضرتك اشرت اليه فعلا، وهو اذا كان الهارمونكس احنا اتكلمنا عليها، وزي ما سيادتك اشرت الساجز والسويلز دول هم برضه فاكتس بتاثر في الشبكه. لكن انا كنت بحاول ان انا اوضح ان بعض الناس كانت بتفكر بس في الكواليتي as a quality والreliability is a part of the quality، ولكن كان يعني منفصل عن الجزئيه بتاعه الهارمونكس. لكن بتؤثر في ان زياده الهارمونكس في السيستم والساجز والسويلز وكل اللي حضرتك اشرت اليه بتؤثر في اكثر في زياده الانتربشن في السيستم. يعني وجود الهارمونكس او الساجز او وات ايفر بتبص تلاقيها بتؤثر في السيستم، بيحصل لك unexpected fault، وهذه الانكسبكتد فولد will reflect على الريلايبيلتي. ده بالنسبه لاول سؤال اعتقد ان هو ده. تاني سؤال كنت حضرتك بتشير اليه ان الريلايبيلتي، او ثالث سؤال هتكلم عليه الريلايبيلتي، ازاي ان احنا نعرف اذا كانت الاندسيز اللي هي الصيفي والصيدي اعرف انها كويسه ولا لا ازاي؟ هي الاندكسز بتاعه الريلايبيلتي cannot be measured زي الفولتج مثلا. اقول لك ان هو اي تريبل اي ستاندردز بتقول انها بلس اور ماينس 5%، لكن لا، هم بالنسبه للريلايبيليتي اندسيز بيستعمل حاجه اسمها بنش ماركينج. والبنش ماركينج هو بيشوف ذا بيست بيرفورمانس اول اوفر ذا وورلد، واقدر ان انا اقارن ما بين السيستم بتاعي والسيستم بتاع اي دوله اخرى. فلا يوجد ستاندرد ان انا اقول لك الصيفي لازم تبقى في حدود مثلا 2 3 او بلس اور ماينس قيمه معينه زي الفولتج او الكرنت. فهي بنش ماركينج. بالنسبه للسؤال الثالث، وهو حضرتك كنت اشرت الى ان عندك في المنطقه الجنوبيه اكثر من 2 اوتو ريكلوجر بتعمل لك مشاكل. حقيقه الامر هو according to the configuration of the network. يعني في بعض النتورك فعلا زي ما سيادتك اشرت 2 اكثر من ذلك هتعمل لك مشاكل اكثر من الاقل من ذلك، لكن according للكونفيجريشن والسيستم انتركونكشن نفسه لازم يدرس بصوره جيده. اعرف ان انا يعني السيستم يمكن ان انا وضحته ان هو تو لمب بحيث ان هو متغذي من جهتين، فانا حطيت فعلا اوتو ريكلوجر في اماكن اقدر ان انا افصل من ناحيه واغذي من الناحيه الاخرى. فالعدد بتاع الاوتو ريكلوجر is not too limited to 2 زي ما حضرتك اشرت، لا هو dependent على النتورك كونفيجريشن وشكلها ايه، والعدد يجب ان يكون دراسه تحدد النقطه بالظبط اللي هي ممكن من خلالها اقدر ان انا زياده الاوتو ريكلوجر هتقلل لي الفولت كارنت وتحسن لي السايدي والسكايدي والريلايبيليتي اندسيز. اتمنى ان انا اكون
شكرا.
شكرا.
اي سؤال؟ احد فوق عنده سؤال؟ اخوان ترى في ناس فوق ما تدرون. في احد عنده سؤال؟ تفضل ابو سعيد.
سؤال الاخ سامي والاخ يهاب. طبعا البرزنتيشن what you presented for تحسين الافشنسي اللي هو SPG اللي هو سمارت باور جنريشن. لو لاحظت العرض اللي قدمه الاخ يهاب ويتكلم عن البروجرس اللي قاعد يسويه الشركه السعوديه للكهرباء، فعلا يوضح التوجهات اللي ماشيه بخطى وتنفيذ المشاريع سواء في النتورك من الدي سي وخلافها، واضافه الكومباين سايكل والريتش التارجت اللي هي من اهم اهداف مبادره الجنريشن واللي هي الافشنسي 47. فهذه كلها وضحت لتوضيح للبرزنتيشن اللي انت ذكرته فيما يخص الوصله. السؤال ان ما رايت في الفيزيبيليتي ستدي واضحه في عرضك يتحدث عن الاوبريشن مينتنس كوست هاو ات ويل بي افكت، يعني مقارنه بالاذر تكنولوجي. شكرا.
طيب اشكرك على السؤال. الحقيقه هو احنا لما نتكلم على الاذر تكنولوجي طبعا لا شك انه حتى في بنائنا وتطرقنا لاستخدام التقنيه كتقنيه واتسيلا والحاجه اللي تقع في جانب الشركه السعوديه للكهرباء، كان اللي يجمعنا هو الهدف بزياده كفاءه المنظومه الكهربائيه. هذا في البدايه. من ثم الشركه زي ما تفضلت لها اجتهادات كثيره وكبيره في مجال توليد الطاقة، في نقلها، وأيضا حتى يعني على مستوى الدولة اللي تكلمنا حتى في الكونسيومر سايد there are a lot of initiatives شغالين عليه بحيث إنه نرفع من كفاءة المنظومة ككل. اللي تكلمنا عنه في تقنية واتسيلا هو تفويت الفرص المتاحة. كيف هذا يكون؟ الامباكت من ناحية اللود فاريشن. الآن اللود لو أخذناه بطريقة إنه ستاتيك وإنه فلات، هذا لا يتماشى مع الواقع. تحليلنا لللود بروفايل لابد ان يكون بطريقه دايناميك توضح هذه الارتفاعات والانخفاضات، وهذه الارتفاعات والانخفاضات نبحث لها عن تقنيه بحيث انها تخفف الضرر الناتج من هذه الارتفاعات والانخفاضات. فلما تكلمنا عن سمارت باور جنريشن او بالتحديد واتسيلا تكنولوجي، كنا نتكلم ان هذه التقنيه لا تعاني من كثرة التشغيل أو إطفائها. التشغيل ستارت اب وشت داون كوست ما في مقارنة بالأذر تكنولوجيز. كذلك لما نعمل ديجريديشن أو اوبريشن لليونتس هذه على lower capacities up to 25%. We don't suffer also ولا jeopardize اللي هو كفاءة المحطة ككل، لأن هذه الوحدات أقصى سعة بكل وحدة تقريبا نتكلم على 20 ميجا واط. فلما تبني عدد وحدات أكثر في المحطة الواحدة وتنزل بحملك في المحطة نفسها، فأنت تستطيع إيقاف وحدات، وبذلك بقية الوحدات تكون دائما تشتغل على قدرتها القصوى، وبالتالي لا يتم يعني ما يكون هناك تأثير على كفاءة المحطة ككل. هذا ما يخص. أتمنى أنه كانت الإجابة وافية للاستفسارات.
سامي يعطيك العافية. معليش because of the time يعني very sorry. I have just one question here. Maybe either I will answer it or Burami might answer it. The question is, there are operation indices in generation used in SEC long time ago. Are these indices used in SEC distribution? If not, is there a plan to use them in the future in distribution? In generation, I'm sure that the one who asked the question is from generation actually. The main indices or KPIs is the availability, reliability, efficiency, and distribution also they have their own, which is linked also the reliability, efficiency, and availability, of course, the number of customer interruptions, the faster the restoration of the time, the SAIDI, the SAIVI, all these are, they all boil down to the same reliability, efficiency, and availability. So I will answer the state of it. At the end, I would really thank all the presenters here, and maybe we took a little longer time, but it's really worth it. All the presentations were really excellent, and we thank you also the audience for listening. So thank you very much.
شكرا سعادة رئيس الجلسة. أيضا يكرم الآن المتحدثين المشاركين في فعاليات الجلسة الأولى. أيضا نتشرف براعي الملتقى سعادة رئيس القطاع الغربي المهندس عبد المعين بن حسن الشيخ ليكرم المهندس خالد الطعيمي رئيس الجلسة الأولى. شكرا جزيلا لاستماعكم. تبدأ فعاليات الجلسة الثانية في هذا الملتقى في تمام الساعة 11:10 الجلسة الثانية والتي يرأسها المهندس محمد بن سامي بخاري مدير إدارة هندسة التوزيع. أيضا ننوه بأنه يمكنكم طرح الأسئلة التي ستصل مباشرة لرئيس الجلسة عن طريق الابليكيشن.
بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. Welcome everybody, welcome back everybody, and we are here very happy to conduct you with the second session. And the session will contain 4 papers. Inshallah ta'ala, we'll start the first paper for core factor correction and harmonic filtering concepts. The presentation will be presented to you by Engineer Firas Nabil Aziza. Engineer Firas Nabil Aziza is a sales and marketing manager of power quality for Schneider Electric. Firas holds master degree in engineering from IMPL France. He joined Schneider Electric in 2008 as a low voltage marketing manager. Currently equipped with an MPA degree in global management. Firas took over the power solution sales and marketing position, handling the meter, the power factor correction offers. Firas, stage is yours.
Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everyone. My name is Firas Azizi. I'm heading the power solution at Schneider Electric, and my presentation today will talk about power factor correction and harmonics, concepts and solution. Okay. Now, as you know, this session is about electrical power efficiency. So I would like to start my presentation to tell you the life cycle of energy efficiency. What is energy efficiency? Energy efficiency is not stop using the energy because I want to save it. Energy efficiency is about using the energy more efficiently, more wisely. So the first step toward energy efficiency is the measurement. You cannot act or understand what is your savings unless you measure. So the first step in our energy efficiency life cycle is the energy audit, energy measurement. You need to measure to understand what is your savings and act accordingly. For the action, we have 2 ways to do it. Either passively, by having some low consumption devices, some power factor correction. So when you install these devices, you are saving energy. There is no action to be done. Or you can have an active energy efficiency. We need to act to save energy. For example, like home automation, lighting control, BMS. There is automation. There is a way to measure, to audit, to see what is the saving, what's happening. So this is a life cycle of energy efficiency. Need to measure, understand what is the savings, and act accordingly, and measure again if you sustain these savings. Okay? So this is the first slide. Now for power factor correction, the concept. I will give you a simple example, a horse pulling a boat in a river. Okay? So if the horse could walk on water, we are using the maximum horsepower to drag the load in the river. So we will have the phi between the horse and the river equal to 0. So the cosine phi of this 0 will be unity. So if we have a cosine 0 equal to 1, we are using the maximum power of the horse to drag the boat into the river. However, if the angle between the horse and the river increase, so the cosine phi will be less than unity, so we are not using the maximum power of the horse. We will have a lot of losses. Okay? So our best case scenario is to have a cosine phi equal to 1, so the phi equal to 0. This is in general the concept. Now moving to the electrical field. The horsepower in our real life is the apparent power, the kVAs of our transformers. So the kVAs of our transformer is divided to the active power and the reactive power. Our main issue, our main objective is to use all the kVA as active. Okay? So the power factor in real life is the active power divided by the total power of the system. It's called cosine phi. This power factor is a measure of efficiency. How much you are using from your kVAs as active power. So this is the power factor in general. Now, usually, this is the utility giving us the kVAs. It's up to us to use it as active power and reactive power. However, if we install power factor correction at our sites, we will be supplying the reactive power internally and having all the kVAs from utility as active power. Active power is used and transformed into mechanical power. However, reactive power, which is necessary for the system, is a loss. We cannot use it as active power to be transferred to mechanical power. So our main objective is to use all the kVAs as active power and supply the reactive power internally with capacitor, with power factor correction. Now let's take a practical example. This is a real life example. We have a transformer of 30 kVA with two loads, identical motors of 250 kilowatt, and cosine phi of the system is 0.75. Now I'm a design and engineer. I need to know how much kVA I need for the system to run these two motors. So the simple formula will be the apparent power S equal to the total load, which are the two motors, 250 by 250, 500, divided by the cosine phi of the system, which is 0.75. So the transformer needed for the system is 665 kVA, and we have only 630 kVA. So it's our job to pay extra money and to buy a bigger transformer to supply this kVA, okay? However, there is another solution. We can install a capacitor bank. We can improve our power factor. So by installing a power factor correction of 230 kVAR, we will be having new cosine phi of 0.92. So the new apparent power needed for the system will be 500, because we have the same motors, we didn't change everything. 500 divided by 0.92, the new cosine phi will be equal to 543. So the outcome will be, first, the transformer is unloaded. 2, we will have 87 kVA extra to use. And 3, the electricity bill is reduced. So guys, this is a real life or savings. And it happened one time in Jabal Omar. We didn't have space to install a new, bigger transformer, and we installed a capacitor bank to have some extra kVA in the system to use it. Now, another benefit for power factor correction, as most of you know, heating in cables are losses. And when you have current or reactive current in conductors, these conductors will heat and will create a power loss. And of course, the joule losses will be Ri square. These losses will be in the system. So when we reduce the reactive power, we reduce the reactive current in the system, and we reduce the power losses. Another benefit, capacitor can reduce up to 2% of the total load. And finally, we are saving on electricity bill. Here I want to show you that Saudi Electric Company is one of the among the few first utilities in the region to implement the power factor correction penalties. Nowadays, any industrial, governmental, and commercial consumer who has more than 1 MVA capacity, they need to have a minimum power factor of 0.85. However, if they don't, they need to pay penalty. And here we can see two of our precious customers shared with us the electricity bill to show us that, guys, people are paying money, are paying penalty for the low power factor. Here, first customer is paying 1,000, here 20,000 real penalty. So by installing capacitor bank or by improving their power factor, they can reduce their electricity bill. Now we spoke about the concept and power factor. What is power factor? Why it's needed for the system, and why utility are putting penalties on low power factor. Now we speak about the solution. The solution for power factor, for low power factor, is the capacitors, the capacitor banks. So Schneider Electric, like other manufacturer, we are supplying either the loose component for local panel builder to build their own capacitor banks, or we can supply complete capacitor banks, low voltage and medium voltage, or we can supply the new technology, the new capacitor bank, which is working on IGBT and thyristors, and it's electronic capacitor. It is working on the current injection method. So these are the solution of low power factor correction. And nowadays we are supplying a lot of capacitors to improve the power factor at our customer site. Now, of course, for everything related to electrical components, we have some standards and regulation. For the IEC, which governs the capacitors and the low power factor, we have the IEC 61921. This international standard governs the low voltage capacitor bank and the power factor correction. However, in Saudi Arabia, we had this specification for the capacitor of power factor correction, which is 43 SDMS03. And the Saudi Building Code and SASO are mentioning the power factor correction in their specification. So this is, guys, to show you that we have international standards which govern this business. Now harmonics, as Mr. Professor said about harmonics, is very dangerous for a system and will have a lot of interruption in your system. So harmonics is a major issue nowadays. Harmonics, if you can see, it's an integer multiple of the fundamental frequency that when added together result in distorted waveform. We will not have a perfect sinusoidal waveform. Here you can see we have the 60 Hertz waveform, okay? And we have the third harmonic, and the fifth harmonic, and the seventh harmonic. All together will create a distorted waveform. So when you have oscilloscope or a meter and you measure your waveform, you will not see it a perfect sinusoidal. You will see it distorted, a lot of harmonics in it. So from where these harmonics comes? Of course, it will come from computer, faxes, copiers, VCD drive. To be honest, it comes from anything electronic. And of course, nowadays, you know that everyone has a laptop, everyone has mobile phones, electronics are everywhere. So as we are having new technologies, harmonics are getting worse and worse. So it's our job nowadays to find a new technology to correct it and to have a solution for this. Now, why always when we mention the capacitors, we need to focus always on harmonics? And why vice versa, when we speak about harmonics, we need to take care if there is a capacitor system? As most of you know, the impedance of the capacitor, we have a low impedance for a capacitor, and it's related to frequency. And harmonics are high frequencies, third, fifth, seventh harmonic. So when we have high frequencies, the impedance of the capacitor will go even lower. And of course, as you know, the current is like water, goes with the easiest flow. So when the nonlinear current and the current from harmonics, we'll see that there is low impedance system, which is a capacitor, directly to the flow to the capacitor. And the capacitor will heat, and believe me guys, some days it will explode, it will have a big boom. So we need to be careful when we install capacitors. We need to be sure there is no harmonics in system. We need to have a study. We cannot just install capacitor and forget about it. We need to see if there is harmonic system. Once we have harmonics, we need to have harmonic filter to correct these harmonics. Then we can install capacitors and power factor correction. Now, the solution, how does it work? The harmonic filter, how does it work? The harmonic filter, our aquasine, will measure the level of nonlinear current. It will see here. Okay. Presentation. Video. Okay. So the aquasine, the harmonic filter, will measure how much nonlinear current we have in system and inject the opposite of it. Now, because seeing is believing, I will show you a simple video where we really correct the harmonic system. This is a waveform where we have a motor drive. Okay, this is a waveform. It's not sinusoidal waveform. It's distorted waveform. A lot of harmonics in it. Okay. So here you can see this waveform we see on each phase 520 amps and 30% total harmonic distortion. I want you to remember these numbers, 517 and 500 and 28% total harmonic distortion. So we have a lot of harmonic system. This is a single line diagram of the system. We have the source. We have our active filter not yet on. We have the motor drive, which is creating a total harmonic distortion of 30%. Okay? So now we ask our friend Julio to turn on our aquasine. Okay, pause. So you can see here, less than second. It's only just turning my iPhone like this. And you can see instead of having distorted waveform, we have perfect sinusoidal waveform. Then if we look at the load and the phase, we see that we have 500, we are saving energy, it used to be 520, and we have less than 1% total harmonic distortion. Okay, so this is the solution. Now, presentation. Now this video showed you how we really can improve our network by using nowadays technology. Now this is the solution, okay, and how the outcome of the active filter will be perfect sinusoidal waveform. And finish. And I want to conclude by telling you that Prophet Muhammad ﷺ said, "لا تسرف ولو كنت على نهر جار." It means do not waste water even if you were on a running stream. Energy efficiency should be part of our DNA. Nowadays, God gave us a lot of resources such as oil and gas, water, metals. So it's our duty to save it for our kids, for our grandchildren, and for the future generation. Thank you very much, and that's it from my part.
Thank you, Franz, for this valuable presentation, very valuable presentation. And I'll present you now. Please, I'd like to request you that we keep all the questions to the end of, inshallah, this session too. And the second paper in this session will be for the subject of reactive power control and optimal power flow. And this will be presented by Engineer Saleh Bamasak. Engineer Saleh Bamasak is the Department Manager of System Operation and Control in Saudi Electricity Company. Saleh holds a master's degree in electrical engineering from King Fahd University for Petroleum and Mineral. He is a member of SIGRI B5 for Protection and Automation study committee, and he has published several technical papers in different international conferences. Floor is yours, please.
يعطيك العافية بريان. السلام عليكم ورحمة الله وبركاته. بسم الله والصلاة والسلام على رسول الله وعلى آله وصحبه وسلم. وأسعد الله صباحكم ومساكم بكل خير. In this presentation, inshallah, we'll talk about the reactive power control and optimal power flow. I will start, inshallah, my presentation by giving an introduction on the major task of people sitting in the control centers. As you know, people sitting in the control center, they are doing or generating the power from the generation power plant, then transmitted, and finally distributed to the consumer. And most of the major important task they are doing is monitoring the frequency. By simply, they are balancing the load and the demand and the generation. And also, they are doing also another important task, which is monitoring the voltages. Monitoring the frequency is very easy by balancing supply and the demand. If the supply is more than the demand, the frequency will increase. And of course, if the demand is more than the supply, the frequency will decline. Is this enough? Actually, it has been reported for many interruption or disturbances, major blackouts worldwide, that there was another reason that caused this interruption and blackouts in power system, which is the voltage instability. So voltage instability is as important as the frequency instability or angle instability. Now, how I control the voltage? In this figure, I will inshallah explain or give you a brief idea on the tools that help us in controlling the voltages. Actually, reactive power is related to the voltages. And assume here we have a tank of reactive power, and we can measure the level of the voltage
by indicate the level of the reactive power in that tank. How can I supply reactive power? We have elements that help us in supplying reactive power. Some elements not controllable, and there are some other elements which are controllable. In the same time, there are elements that absorbing reactive power. Some of them controllable and others are not controllable. Capacitor, long overhead line with lightly loaded cables, all of those are supply or sources for uncontrollable reactive power. On the other side, we have generator units, SVC, STATCOM, synchronous condensers. All of these units are controllable sources for capacitive reactive power. In terms of elements, those absorbing reactive power, we have reactor, heavy loaded tie lines are absorbing reactive power, loads of course absorbing reactive power. Those uncontrollable elements absorbing reactive power. There are some other elements controllable absorbing reactive power, the thyristor control reactors, generators, and of course synchronous condensers. Having said this, we can move now, or before that, as a conclusion of this point, when you have a capacitive reactive power or inductive reactive power more than, or the capacitive reactive power more than the inductive, you will have an overvoltage. And if you have an inductive reactive power equal to the capacitive, you have the flat voltage. And if you have the inductive reactive power more than the capacitive reactive power, of course you will have under voltage or low voltage. So it is very important for people sitting in the control center to do controlling the reactive power in order to maintain a flat voltages. Now the optimal power flow. What is the optimal power flow? The simplest form of the optimal power flow is the economic dispatch. When we assume that the generators and the load are connected to the same bus bar, and we have of course the objective, we are minimizing the cost. Simply, I will operate the cheapest generator in that bus bar in order to supply the load. But as you know, this is not the case. Usually we have a network, hundreds or thousands of transmission lines, transformers, a lot of elements between the generation power plants and the loads. So the economic dispatch by the concept of having them all in the bus bar is not applicable here. Now let's have this example. We have two generating units. One of them is by the cost of the generator in bus A is $50 per megawatt hour, and the cost of the generator in bus B is 100 megawatt hour, $100 megawatt hour. And of course we have two loads in bus A and bus B. The maximum now here, the power flow in each line is 100 megawatts. This is a very simple example. How to operate the system? Definitely, I will take the whole power from the cheaper generator. I will supply the system by 300 megawatt from the generator at bus A in order to achieve or reach to the system demand. The power flow is 100 megawatt, which is acceptable because we know that the lines can accommodate this value. Now let's change the load at bus B to 400 megawatt. The previous solution will be no longer acceptable. If we operate the system based on the cheapest generator, I will deliver 500 megawatt from generator at bus E, at bus A, but I will face a problem because the flow of each line will go to 200 megawatt, which is more than the capability of the lines. Now here we have a constraint. Of course, the optimal solution is to operate the system by supply, from generator A 300 megawatt and 200 megawatt from the generator B. Now, the optimal power flow, it is an optimization problem, as each and every optimization problem has an objective function. Usually, the objective function is to minimize the cost of the generation. Of course, with a constraint, because each optimization problem has an objective and has a constraint. In the optimal power flow, we have an equality constraint and also we have an inequality constraint. The equality constraint, as you know, is the power balance at each node. And of course, the inequality constraint, the network operating limit, the line flow, the voltages, the limit and the control variables, the tap changers, all of these elements. And this is the mathematical formulation of the optimal power flow. We have a minimization of the objective, of course, with the subject to constraint, equality and inequality. What is usually the output of the optimal power flow? Optimal power flow will give you the power from each generator, and of course the voltages at each buses, and the line flow in each of the transmission line within the acceptable limits. So what I have done, actually I have developed a software that can give you an optimal power flow for any system. The software, starting by, it has a lot of subroutines and using some sophisticated optimization tools. I will not go into detail about how the optimization algorithm work, but I will give an overview of how the code is working. The code will start by reading the system parameters, all information about the system, and then the optimization algorithm will start by giving an initial solution, and of course after that we'll go and run the normal load flow. We'll check the objective, and then we'll in each objective we'll check the objective function. We'll take the solution that gives the minimum objective function. Then we will check whether we satisfy the stopping criteria. If yes, we'll print the result. If no, we'll go again to the optimization techniques and update the solutions. I have applied this software for the IEEE 30 bus system. This is a well-known system. It consists of 6 generators and 4 transformers and 41 transmission line and 9 capacitors. I set actually the objective function of the code to minimize the cost. Each generator has a cost, and the cost representing by a quadrature equation. Those are the constraints used in the code. We have the equality constraint and the inequality constraints. Of course, in inequality constraints, we have the voltages limit, we have the power generator limits, we have the reactive generator limits, we have the tap changer limit for each transformers, we have the capacitors at each bus bars, and of course the voltages at the load, and finally the transmission line rating. This is the simulation output. In the last column, you can see here the output of the IEEE 30 bus system. In the first group is the output of the generator output. and here the output of each generator bus voltages, because those are controllable elements. And we have the transformer tap, which is also a controllable element. We have usually a tap ranges. And the capacitor bank, where to operate the capacitor at which bus bars. And finally here, some indicators which I will focus on. Now, in the first column, you can see the initial solution without optimal power flow. The fuel cost of this system before using the optimization techniques was 901. Here, then the second indicator is the voltage deviation, how much the voltages is deviate from 1 per unit at each bus bar. And the third one is the power losses. We can see when we apply the optimization techniques, we reduce dramatically the cost, the fuel cost of this system to 800.39. And then we have the voltage deviation and the power loss. We calculate these indices. I would like to indicate here the objective function was to reduce the generation cost. However, we calculate the other indicators. Okay, now if someone said, if someone said, no, you have a very high power loss, I need you to change the objective function in order to reduce the power loss. Okay, I will go back to the code. I will change the objective function in order to, I will change instead of reducing the cost, I will reduce the power loss. And I will place the equation to calculate the power loss in the power flow problem. And I got this result. I have successfully reduced the power loss from 9.06 to 3.1. But look here. The cost has been increased to 967. Is this acceptable? We don't know. Now, let's change the objective function to be more focused on the system voltages, system security. Let's change it in order to minimize the voltage deviation, so that we want the whole buses in that system, the voltages in all buses in that system to be reached to almost 1 per unit. Again, we'll change the objective function. We'll put the objective function to calculate how much the voltages is deviating from the reference 1 per unit. We want to minimize this objective function. And finally, I got this result. The voltage deviation has been reduced, and we got an acceptable fuel cost to 806, and the power loss. But again, we have a very high power loss. Here, actually, because of time, I could not present to you because I reformulate the objective function. Instead of having a single objective function, we have a multi-objective function. But because of the time, I could not really present the result of this objective function and how it is formulated. So, it is not usually right to operate or to put the objective function of minimizing the cost. So, you need to have a multi-objective function. You need to look at your system. Sometimes you operate a costly generator because it helps you to maintain the system security. I have applied the same simulation for a bigger network, IEEE 57 bus system, and also I got a result for that. I will skip that because of the time. In conclusion, in this paper, an optimization algorithm has been proposed, developed, and successfully applied to solve the optimal power flow problem. The OPF has been formulated as a constraint optimization problem when several objective functions have been considered. The proposed approach, of course, has been tested and examined on the standard IEEE system, the 30 and 57. The result demonstrates the effectiveness and the robustness of the proposed algorithm to solve the optimal power flow. Thank you so much.
Thank you, Sarah, for this very academic presentation, and a very excellent one. The third paper will be for improving the efficiency of energy generation in electrical power plants. Our presenter, engineer Alejandro Azmitia. Alejandro is the sales project manager for new station and services business in the Siemens Energy Solutions sector in the Middle East and North Africa region, based in Dubai. Please, Alejandro, floor.
Thank you very much. Good morning, gentlemen. Thank you for having me here. It's an honor to be able to present to you my subject. I hope you find it as interesting as I do. I'm going to be talking a little bit about how to improve the efficiency on combined cycle power plants. In order to talk about efficiency, you have to evaluate case by case, and you have to be very accurate on each power plant. So I'm going to try to keep it very general and very broad, so it sort of applies to all cases. As we all know, the temperature variation during the year has one of the main drivers of the power demand on the grid. So in case of the kingdom, when the temperature is at its highest, it's also when the demand is at its highest. Sadly, due to the natural behavior of combustion machinery, it's at this point where the machines perform the least. Internal combustion engines, as we all know, have a very low performance at high ambient conditions. So ideally, I would have a machine that would run with the power demand, but this is not the case in Saudi. So this means that in order for me to design my grid, or the design point of the grid has to be able to meet the worst case condition, which is the peak load hours at the hottest day. This automatically means that my grid is over-designed the rest of the year. So that means that most of my units will have to be run at part load or be shut down. And that, of course, has a major economical impact. So as we all know, part loading a gas turbine and in general the combined cycle has a pretty big impact on, a negative impact on efficiency. As we can see of this example, operating a unit or a power plant at 70% of its capacity takes about 2.5% efficiency loss, which, depending on how we evaluate, it can have up to $200 million in net present value losses. So operating at part load is, in our case, or in every grid, unavoidable, but it should be reduced. So in order to accurately describe what's happening during this part load, I've come up with this variable called relative efficiency. And the relative efficiency basically describes my block efficiency running compared to its main efficiency. So the relative efficiency tells me if my block is running at base load or at part load. And I can see that by dividing the efficiency at the current power demand, which would be part load, for example, divided by its maximum efficiency, which would be base load. So let's take an example of a block that will be 3 times 3 on 1, for example, running at 1,500 megawatt because my demand is this. The block loses on efficiency because it's running at part load, basically making the relative efficiency at about 97%. And as I said, about 3%, 2.5 to 3% losses on efficiency due to part load have a big toll on net present value. So how do we minimize this? That's the good question. If I see the power plant output and I evaluate its relative efficiency during its complete power capacity, I can see, let's say, in this example, a 3 times 3 on 1 running at part load, you see how the efficiency lowers and then increases again as the gas turbines are being shut down or started. So if I define 97% relative efficiency as a good part load efficiency, this block would give me about 350 megawatts of efficient part load operation. So this block can run as low as 700 megawatts efficiently before it takes a big toll on an economic value. If I take the same example and on a 1 times 4 on 1, with also the same relative efficiency of 97%, we can see that this solution has an increased part load band. So I can run a block 4 times 4 on 1 with more part load or efficiently at a bigger part load than a 3 times 3 on 1. Than just a 3 on 1. And in general, the idea is the more turbines there's on a block, the more efficient this block can run. Of course, there's a limit on turbines per block. I cannot put six turbines on one steam turbine. At least on Siemens experience, 5 times on 1 is as big as we could manage. Anything bigger than that we wouldn't suggest. And I think also for any utility doesn't want to have a steam turbine that big. So how do we solve this issue? To install or to plan this block under a common steam train. And a common steam train basically unites all my turbines with my steam turbines, and I can have a block that is connected, and I can have a block that is in theory limitedly big, and also connect my steam turbines that are also a limited amount. The size of the steam turbine is not dependent on the amount of gas turbines either. So I can have 3 gas turbines with 2 smaller steam turbines instead of 1 big one. That, of course, increases my flexibility, also my part load efficiency. So let's say on this example, 5 on 2, which is a pretty unconventional solution, we can see that a 5 on 2 working on base load has 100% relative efficiency, whereas running 3 on 1 also has a pretty high relative efficiency because the steam turbine is still running at base load. And it could also run on a 2 on 1. The steam turbine would be running at a pretty high power output as well. Nevertheless, this has also a lower relative efficiency. So to summarize this subject, here's an overview of 3 times on 1, 4 on 1, and 5 on 1. And you can see in percentage how far it can run until the relative efficiency becomes too low. And we can see that unconventional blocks, let's say, this was a wild example, but a 7 on 3 has a very high part load efficiency, and it could run as low as 25% and still be pretty efficient. So I have on this example, again a wild example, the 7 on 3, I can run 1,800 megawatts with a very high efficiency, relative efficiency above 97%. So again, the common steam train allows us to have a lot of gas turbines with several steam turbines with different size, and gives us the flexibility and part load efficiency. So another way to reduce my over-design of the grid is by implementing power augmentation measures. In this case, we offer a system called wet compression. And wet compression injects a certain amount of water into the compressor inlet, and this increases our output. By increasing our output when we need, on demand, on the push button, we are more flexible to cope with our variable power demand. So I can automatically assume that if my units can be upgraded on demand by 10%, I can reduce my capacity by 10%. Basically saying I will only use that extra power when I need it. So here's a little example of a gas turbine. It's a 4000F, 50 hertz, running with wet compression. There's an upgrade that can be done to all the fleet, and there's this water rack that is installed, and this injects this very, very small water droplets into the compressor inlet, which then gets compressed, and thus increasing the compressor efficiency with the intercooling effect, and also increases the turbine mass flow. By doing this, we can increase the power output of the combined cycle to about 10 to 15%. We can also combine this with chillers and evap cooler to further increase the power output. But the beauty of this system is it can be activated on a push button, so only when I need it. Basically, increasing also my part load. I can design my grid and then increase this only when I need it. So there's no over-design, there's no unneeded over-design. With this wet compression, I have a controlled water, and the power output of the combined cycle is controlled by the water flow. We optimize the droplet size to keep it very, very small droplets to avoid erosion and corrosion. And with this, with our system, we have a lot of experience with injecting high flows of demineralized water. We can see about 10 to 12 kilos per second of demineralized water per gas turbine. This is more or less the maximum flow that we can achieve. So as I mentioned, not only we increase the power output, the efficiency of the gas turbine is also improved. Even 0.3% efficiency can mean on a 25-year power station substantial savings. Another really good advantage about the system is that it's weather independent. As we all know, evap cooling is dependent on the relative humidity of the ambient. If the humidity is high, my evaporative cooler won't have that much of an effectiveness. Unlike the evap cooler, the wet compression is unaffected by the ambient condition. So we can see in this graph relative humidity from 0 to 100, and we see the power output of the wet compression not being affected, or being slightly affected, let's put it to be fair, by the relative humidity. Unlike the evaporative cooler, which loses efficiency as the humidity increases. Another measure of increasing the part load efficiency and the power augmentation is the so-called compressor turn-up. So the compressor, or the IGVs, inlet guide vanes, are designed to have a maximum flow. On some sort of turbine models, we can increase this flow on demand as well, also increasing our power output, also on push button, which again improves our over-design of the grid. And last but not least, this is a Siemens system as well. It's called hydraulic clearance optimization, where the gas turbine's rotor is moved in operation, actually at base load, is moved forward by about 3 millimeters. And this helps us reduce the gap of the turbine, and so increasing the turbine efficiency. This again is in operation. Yeah? Hydraulic clearance optimization can be found in all H-class gas turbines from Siemens. And here we can see that once the gas turbine has heated up fully, I think it's about 1 hour of operation, the system automatically moves the rotor forward, and so closing the closing the gap of the turbine, and we can see about 5 megawatts on power augmentation by doing this. Per turbine. So these are 4 of several options that we have to improve the efficiency and to have power augmentation in the combined cycle. By adding these, or by upgrading the combined cycle with these power augmentation measures, we can reduce the over-design of the grid. So I recommend it. Thank you very much.
Thank you, Alejandro, for this presentation. And introduce you now the last but not least, the 4th paper in this session. Subject name is Rule of Cooling Techniques and Fuels in Enhancing Power and Efficiency of Gas Turbine Plants. Our presenter, Mr. Mahbub Basha, is an engineer, second engineer in the Center for Engineering Research at Research Institute King Fahd University for petroleum and mineral. Mahbub has been actively involved in a research project in the area of computational fluid dynamics, stress corrosion, heat transfer, and gas turbine power plant design. He has published more than 25 technical papers in reputed journals and international conferences. Mr. Mahbub, floor is yours, please.
Thank you very much. Assalamu alaikum. Today I'm going to present a paper on role of cooling techniques and fuels in enhancing the power and efficiency of a gas turbine. In the earlier presentation, one of our colleagues presented the wet compression, so more of our presentation will be in the same lines, but my presentation will focus on the economics of the incorporating wet cooling, wet cooling, and also the changing the fuels during the operations. So my outline of the presentation is, I will just introduce the problem, and then I will start with the methodology and some of the assumptions used in the simulations, and the results and discussions, elaborating the economic analysis, and also the impact on the output of the power plant. And finally, I will conclude with some of the remarks during the studies. To start with, this is a axial turbine. Air is sucked in the inlet, and it goes to the compressor, and then it goes to the combustor, and then it goes to the turbine side. So during the operation, the power generated at the turbine is partly used to compress the air. So I can say 40 to 50% of the power is dedicated to compress the air. In Saudi Arabia, the temperature is so high that the power which is at the power which is given by the manufacturer, that the turbines are designed at ISO temperature. So the peak performance is at the ISO temperature. So due to high demand in Saudi Arabia, so every year there is increase in demand power. So the one of the alternative is that you either go with installing more capacities, or look for the alternative like renewable energy, or in another way, the existing way is to increase the performance itself rather than going to the other alternatives. So there is a lot of scope. You can increase the performance, not just but including the cooling technique, but also the change in fuels also is one of the scenarios where you can try to increase the efficiency of the turbines. So gas turbines are widely used in power generation sector. So gas turbines efficiency actually depends on the mass flow rate through them. So it means that if you increase the mass flow rate, the efficiency will increase. So one of the way of doing it is to cool the inlet air by cooling, by fogging, by evaporative cooling, and also by chillers. So however, in the recent part, there are many studies that focused on cooling technique itself, like fogging, chillers, and also from evaporative cooling. But in the recent study, it was showed that inlet fogging is more effective than other studies because it has the efficiency increases by 1 or 2% at a given condition. So what is fogging? Fogging system has been shown in the previous slide. There is a system wherein water is injected to series of small nozzles which at the inlet stream. So that will reduce that will mix with the inlet stream, and it will decrease the temperature of the density of the air, inlet air. So that will result in compression work. And ultimately that will increase the performance of the turbines. So there are two spraying levels, that is underspray and overspray. We are considering only underspray technology. So there have been a lot of research in this area. I'll not go into detail with the literature. But for the student study, we are focusing on two GT frame size, which is the worst case, 20 megawatts and 40 megawatts. One of the problem in Saudi Arabia is that the water is brackish. So you need to have a soft water for the reverse osmosis. So we have to consider all the economics involved. Like we have to install the reverse osmosis unit in order to have the fogging phenomenon. So our study involves effect of variation of fuels, relative humidity, and also inlet temperature. We used a popular software called GT Pro. So as a performance matrix, what we are looking at is output, plant output, net efficiency, break-even electric price, and break-even fuel price. So power output depends on the mass flow rate to turbine, which I already mentioned. By cooling the mass flow rate, by cooling the air, the mass flow rate is increased, and the shaft, as mentioned earlier, the shaft power is consumed by the compressor is about 66%, which is studied by the previous researcher. So this is the setup wherein you spray small particles of water into the stream that will goes to the air filter and then to the compressor and to the combustion. So these are the consideration, some of the assumptions on the site. Like we have chosen 40 megawatts, and least one is 20 megawatts turbine system. And the fuels we are using gas, crude oil, and diesel. So these are some of the parameters which we consider in the study, like pressure drop at the inlet is 4 inches of water, and we used natural gas, diesel, and bunker oil. And the fog efficiency, for just sake of study, we took it as 85%. Then the operating hours are 8,100 hours, which is about 80 to 90% of the throughout the year. And the fuel price, which is subsidized fuel by Saudi Arabia, which falls in the range of about $1 per MMBTU, and we need to assume the first year fuel electric price, which is about 0.4 $0.04 US per kilowatt hour. Again, we are reiterating the study assumptions here. So this figure shows the effect of humidity on the performance of the gas turbine. On the left hand side, you can see the net output. There is no, as has been shown in the previous slide presenter, there is no effect of humidity on the performance of the plant, even without fogger and with fogger. So RH has been varied from 30 to 45%. This range is prevalent in the Saudi Arabia. So it was concluded that the RH doesn't have any much effect on GT plant performance. So we considered it as to be 30% throughout the simulation. So this figure shows the effect of temperature and net plant output and efficiency for a given turbine. So we did two set of turbines, which is 20 megawatts and 40 megawatts, with three cooling technologies, which is fogger, evaporative cooler, and chillers. But for the sake of brevity, we are mentioning only when we are just presenting the results for fogger with 40 megawatts turbine system. So the ambient temperature ranges from 80 degrees Fahrenheit to 100 degrees, which is within the range of the prevailing range of in Saudi Arabia. So as you can see, the temperature here, the performance decreases with increase in temperature, ambient temperature, and the efficiency also decreases with the ambient temperature. So in our study, it can be seen that for GT only situation, for a decrease of ambient temperature, inlet temperature was about 10 degrees Fahrenheit. Plant net output and efficiency want to increase by 4% for all fuels. This figure shows the effect of temperature and net plant output and efficiency of the given turbine. On the left hand side of the figure, the net plant output is on the left side, and the net plant efficiency is on the right side of the figure. So again, you can see that with temperature increase in temperature, the efficiency decreases, and also the net plant output decreases. Coming to the economics of the plant, so far we saw that the efficiency decreases and efficiency and power plant output decreases and increases with the temperature. But what about the economics? We know that the fact that with temperature, with change in parameters, there is a change in the efficiency of the turbine performance. But how much is how much? So we are taking two parameters, that is break-even fuel price and break-even electricity price. So break-even fuel price refers to the maximum price at which you can purchase the fuel from the market, and the break-even fuel electricity price is the price at which you can sell. You can sell your electricity to the customer. So again, here this figure shows the effect of temperature on the break-even fuel price and break-even electricity price. As the temperature increases, break-even fuel price decreases, and the break-even electric price increases, showing the effect of the performance of the gas turbines. So, regardless of the gas turbine configuration, types of fuels used, BFE/EF and break-even fuel price increases with increase in temperature, and break-even fuel price for the natural gas is higher than all other fuels used in the system. This figure shows the break-even fuel price variation with temperature. Again, it has been with the GT with fogger situation, break-even fuel price found to be like 2.2 relative to the other previous studies. That break-even fuel price for natural gas again is the lowest compared to all other fuels. So it is a good for the kingdom itself to use gas turbine with gas LPG, what do you say, liquefied petroleum gas. In conclusion, a computational study was performed to study the efficiency and plant output for two situations. One is turbine without fogger, and one with fogger with gas turbine with fogger. For a decrease in inlet temperature of 10 degrees, the net flow output was found to be increased by 4%. That is the worst case. And the net plant efficiency for natural gas are higher compared to other fuels. And BPF and BPEP was found to vary from $2 per MMBTU to $2.2. And again, BKN fuel price, fuel price from $0.024 to $0.06 per kilowatt respectively. Thank you very much for your attention.
Thank you, Mahbub, for this presentation. And I'd just like to very quickly summarize you what has been presented in these four papers. Firas has presented us the challenge of to design a suitable power factor correction system within the harmonic environment, using the electronic-based devices such as the detuned capacitor, passive filters, and active harmonics. He presented us a new economical solution, how it can be those correction, power factor correction can be produced by eliminating harmonics. Saleh has presented us a optimal flow analysis. He's used a different modern optimization technique actually to solve the optimal power flow problem and determining the optimal setting of power generation units, node voltage, transformer, tab ratio, and shunt capacitor or reactors. Mr. Alejandro presented us the problem of fluctuating power demand between summer and winter, and how that can cause inefficient uses of both single and combined cycle power plant. He presented us a Siemens solution by wet compression and chiller system in order to optimize the performance of the gas turbine performance. Mr. Mehboob also he submitted us a presentation regarding how to really optimize and the performance of the gas turbine units by controlling the air inlet. He's presented that if we could introduce a foggy methods into the air inlet, then it can increase the efficiency of the gas turbine. And now, due to the time limitation, I'll open the floor for Q&A, and by requesting to any person to name himself and the person he wants to direct the question for. If no question, we've got one at the end, please.
Assalamu alaikum.
Assalamu alaikum.
Dr. Rahid Jassim. My question to Alejandro and Mahbub. Is it possible to tell me what are the new methods of cooling system to increase the output power of power generation? Because it seems to me the method that you used or you talk about is an old method. Because I'm not going to tell you when I published the first paper in increasing the power of output, the power, especially in Saudi Arabia, in the hot and humid weather. It's been a long time ago, and there are new methods of how you can increase the output power of the power systems. Can you elaborate on there are any new methods? And what are the disadvantages? What are the disadvantages of the fogging system that you are using? And if I use or inject the water in the combustion chamber directly, is that better than fogging system or not? Thank you.
Thank you very much for your question. Yes, you're right. Wet compression is not new technology. Nevertheless, installing wet compression on H-class gas turbine is new and difficult, especially because the combustion temperatures rise up to 1,500 degrees Celsius. And keeping combustion stability by injecting 15 kilos, 12 kilos per second of water is not an easy task, especially in control systems. We also use chillers, which have the disadvantage of a high auxiliary power, but can also be optimized and be used efficiently. Fogging, nevertheless, has less of a power increase compared to wet compression. So Siemens does not offer fogging systems. We do evap cooling, which is very, very good, cheap, and efficient. Sadly, dependent on the weather conditions, it can be very efficient or very inefficient. And we do offer this wet compression, which many of the GCC customers are currently upgrading their machines to, especially Diva and Dubai, where I'm from, or where I'm working from. They're upgrading their entire fleet to wet compression, again, to increase the power output on demand, which is the very interesting thing about this system, that it can be switched on and off. Nevertheless, there's no other systems we offer for power augmentation besides the ones that are presented.
I have a question for Mr. Saleh. Mr. Saleh, I think because you are making an optimal power flow, and in some, as you presented by Mr. Mahboub and Mr. Alejandro, that if the generation, if there are some units in some part of the year running at part load, then the efficiency will go down. That means the cost will increase. So, and you introducing the methods of foggy system or the solution of Siemens that can increase in case if there is, part of load, the method has implemented, then that will retain the efficiency. So how you could combine between the generation and part load with these solutions, so that can increase the efficiency, and it will reflect also into reduce the cost, the operation cost of the whole system. Please.
Thank you, Brian. Actually, any more, for example, now this is a constraint, right? It needs to be formulated mathematically first and correctly formulated, and then it can be added as a constraint in the optimal power flow problem. Currently, or right now, I don't know how it can be formulated, but it needs to be formulated correctly, and then you can run your optimal power flow considering this new constraints, and you can then look at the results.
Yeah, especially because the power demand is so fluctuating during the year or even the day. You see peak load jumps and base load that is very hard to cope and to control. As our colleagues were presenting, the demand, that balance of demand and supply can be, again, as he presented, optimized with the power flow, and again also with these power augmentation systems. I can avoid starting a power plant or shutting one down by pushing a button. And I can control the power demand exactly as I want. Unlike, let's say, wind turbines or solar power.
You can efficiency as well. and efficiency is also maintained. It will
Very,
go down.
very high efficiency.
Yes.
Which unlike, let's say, green energy, which does what it wants. Yeah. Green energy gives supplies and doesn't as it wishes. And gas turbines, combined cycles, does exactly what I need.
Excuse me, finished?
Yes.
Yes, one last question for Mahbub. Mahbub, you made your study based that you stopped at humidity 40%, and you said this will get no more variation as the humidity will get no effect on the performance of the turbine. But really, as the air becomes more humid, then that means ensure more density, that ensure better performance and power output from the units. We have humidity in Eastern Province area more than 100%. So why you stop at 40? Why you didn't try the 100? I feel those areas under huge humidity, the performance of plant is much better than dry area. Please.
We just considered, as you said, we could have done it, but for the sake of publication, we just considered 30 to 40% according to the publication in the references. So they tried between 30 to 40, and even in the presentation presented by your colleague, what was around 50 to 60%, I think. So, as you said, it can be tested. But again, the question is, from his presentation, from our simulation, the humidity effect is very minimal. It's like 3 to 4%. It's not constant. Yeah, you can see the graph from
more density.
Yeah, but this is what even one of the referees was asking, what is the reason behind this? You vary the humidity from 30 to 40 or 50%. You see only 1 to 2% increase in the efficiency or output. So still, we cannot understand the phenomena. Or it needs more thermodynamic analysis to get an answer for it.
And okay, by this I will announce the end of this session. And I thank everybody for his contribution. And please give hands to our hands.
شكرا للمهندس محمد سامي بخاري على ترأسي هذه الجلسة. نتشرف أيضا بتكريم المتحدثين. أيضا نتشرف بالمهندس عبد الحميد النعيم رئيس القطاع الغربي الشرقي ليكرم رئيس الجلسة المهندس محمد سامي بخاري. لا لأن أنا من الغربي يعني. شكرا جزيلا لكم ولاستماعكم. تبدأ فعاليات الجلسة الثالثة في تمام الساعة 1:20. الآن فترة استراحة وصلاة الظهر المصلى في مدخل المبنى الرئيسي على يدكم اليمين. شكرا جزيلا لكم. السلام عليكم. تبدأ الآن الجلسة الثالثة والتي يرأسها المهندس فهد الأسعوس مدير إدارة التدريب.
الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين. نبدأ السيشن الثالث إن شاء الله اليوم، وأحب أشكر الحقيقة المنظمين الفورم هذا إن شاء الله. ونبدأ إن شاء الله our first session with engineer Ahmed Al-Isa from Saudi Arabia. Briefing about that, the Kingdom of Saudi Arabia is projected to undergo significant population, economics and industrial growth over the next 20 years. Many power generation plants have been established and the huge transmission line and distribution network stretching all over the country. In light of this situation, the next presentation will provide an overview. Major national initiatives were established: the National Power Academy and the GCC High Voltage Lab. Engineer Ahmed is a National Power Academy Manager. Ahmed holds a master's degree in Sustainable Electrical Energy from Georgia Institute of Technology, USA. His experience covers various fields of power system, including engineering, planning, and operation. And he held several leadership positions in Saudi Arabia. Please.
Assalamu alaikum jami'an. Good afternoon, gentlemen. First of all, I would like to thank you for having me today among this distinguished gathering. And the same thing should go to the conference organizer, who really did excellent preparation and organization and heartwarming since we started this journey in the airport. So the purpose of having this presentation and to insist to have it today among the agenda is really to reflect two aspects. First, the job opportunities, which is now currently the big ticket item and challenge facing the national and the Kingdom of Saudi Arabia. And the second item or second point of having this presentation is basically to highlight the role, the leadership role and commitment for SSC when they joined and started their efforts of having these national initiatives from day one. And no wonder in the fact when I came and then saw this preparation, so really they are walk the talk. So my presentation will have two parts. The first part will have slides here to give you a brief about the two initiatives. The second part, I will leave it for the video, and I will concentrate on the National Power Academy due to the time constraint. So please, Mr. Chairman, give me just a reminder 3 minutes before my part.
Okay.
So the outline, basically, I will have 3 items. First, I will discuss here the business driver, why we came up with these two initiatives. What is the trigger that to have national initiatives with these two projects? And then I will go briefly about the scope of each one, the National Power Academy and the GCC High Voltage Lab. Starting with the first element, the business driver. As you can see, the power sector growth is in the Kingdom of Saudi Arabia presents significant growth over the coming 20 years. And 3 areas were highlighted during the first time we conducted the feasibility study for the National Power Academy. We focus on the generation, transmission, and distribution. So it was indicated from day one, from the feasibility study, that we have really a significant increase in the generation. It will reach to around 152 gigawatt, and transmission, which is expected to reach to 127 kilometers,
Similarly to the distribution, it is expected to reach 1,900 kilometers by 2034. This increase shows not only for the base installed capacity, it's also including the expansions that are coming with the coming years up to the 2034. So again, this increase triggered or focused two areas, one related to human development, and the second one is related to the electrical equipment asset. In terms of the human resources, it was highlighted in the study the gap that we are in need to fill with the coming 20 years related to the workforce, the vocational workforce. So looking into the demand and supply curve, it is really indicative to the gap that we have. We need around 65,000 of the vocational jobs within the coming 20 years. This is a huge number when we look to our ambitious plans in the kingdom to be the leader in the energy. So that is represent around 3,200 annual gap in the workforce. And we are talking here real jobs with the skillful Saudis that they can lead the energy sector. When we look to the other aspect of the study, which is related to the electrical equipment, we have analyzed the market. And we found that there is a huge market increase coming, which is expected to be 8 to 10%, which is, this reflects how much we are in need of the electrical equipment in the kingdom. The other highlight is related to the factories. We have around 142 factories only related to the low voltage and appliances. They are not major. We are not talking about major factories. And imagine that this low number focus only around 47 commodities out of 85. So still we are in a big gap in that regard. These manufacturers, we know that they are not doing real manufacturing rather than assembling. And if you look to the local share of purchase volume, it's only 30% related and secured for the kingdom. So that means we have 70%, the majority is provided by the outside. And the last highlight related to obsolescence and aging. It was highlighted these manufacturers that are not addressing this critical element, which is now starting increasing as we go with the aging of this equipment. With all these factors, we anticipated and we envisioned early in 2014 to establish two aspects or two national initiatives. One is related to the National Power Academy, and the other one is related to the GCC Electrical High Voltage Testing Lab. And it was the vision to have world-class, first in kind of these facilities in the region, and for first time. So if we look into the National Power Academy, in the fact, it is an academy focused on the vocational jobs related to energy sector. And 7 founding stakeholders, they took the initiative to start this initiative to the National Academy, including SEC, Saudi Aramco, SWIC, KFUBM, Siemens, GE, and TVTC. So this is the kind of mix of the resources that we have in forming the academy. For the project description or the type of operation that we have for the National Power Academy, we try to have always distinguished features and way. So we have to address the gaps and challenges that we doing in the existing training institutes. So the operational model, it is flexible and sustainable. So we have engaged public, private, and a sponsoring training model. And we have developed also board of trustees, consists members from the founding stakeholders. The locations, we have now 2 locations. The main campus will be in Al-Hassa, and the second one in Dammam. And for the trades, we have identified 21 trades out of 38 during the feasibility study. So the soft start, it will be in the Dammam in the fourth quarter 2016. And the other trade, which is 21, will be in Al-Hassa in third quarter 2018. These are the top priority trades or specialties that will be covered in the academy. As you can see, we have a variety of trades and specialties. Some of them are already exist, some of them are new, and we are focusing on those who will need in the coming 20 years. If we look into the MBA training streams, it will be focused on 3 streams. The first one, which is the majority of it, it will be directed to the high school, the vocational, and they will be in 2 to 3 years program to get diploma. And keep in mind, this is a contract and by employment, so there is nothing here training without a job. The other trades related to professional and the short courses. These are other trades that will be sorted based on the market need and the company's requirements. So far we have completed the feasibility study in 2014, and we signed letter of intent jointly with the 4 stakeholders in the beginning, including Saudi Aramco, SSE, KFUBM, and TVPC. In last year, February, we have started the project and forming the project management. And from here, I would like to extend the thanks and appreciation for SSE management support. At least for me, as I get the support, having part of my team, engineers, they work with me in my office in Saudi Aramco from SSE. And for me, is it the first time I see this extension of collaborations, which will reflect that the really commitment from all stakeholders and ECC to continue on this project. In May 2015, we have got the temporary license for the facility in Dammam, and we allocated officially the facility, which is now under construction, which is now different than Hassan is the greenfield. In August 2015, we have allocated Al-Hassa land. It was free of charge, was offered by Saudi Aramco. And December 2015, we have signed the MOU with 7 stakeholders, and we start the official establishment of the National Power Academy. As I mentioned, we have ensured that we put features and we tackle the challenges that are not existing in the current training institutes. So we ensure to have industry-led training that is come from the end user instead of having just programs. The same thing we have included R&D, applied technologies. Maybe this is the first time to have something related to a level of vocational, not professionals. Also, in terms of the new trade and merging new specialties such as energy efficiency, we have renewable, nuclear, and other trades as I offered to these previous slides. Now, I'm moving to the GCC electrical equipment lab, and the GCC lab will be a world class. It will offer 4 services, including testing, investigation, calibration for the low voltage equipment, and training and R&D facility. The several factors that we try to tie it with the lab, so to ensure successful implementation, we have several. One of them is related to participation of strategic stakeholders, such as SSC, Al-Fanar, Saudi Aramco. So others, they are also contributing as stakeholders. Mandating the testing by GCC countries. Also, we have strategic location. It will be located in the eastern province, so it will be close to the industrial cities. In addition to the certification compliance to ISO and international standards. So, the GCC lab benefits, including the following: design quality, create knowledge economy in the region, localization of manufacturing and services, and this is very important. As you have to increase the localization, you will increase also the jobs opportunities for Saudis, and creation of high-skilled jobs, in addition to applied research and development centers. So far, the status of the GCC lab, commitment from all 10 stakeholders have been made, and land allocated by modern demand 3. Initial round of the capital fund completed, and the CEO was appointed starting January 2016. So by this, I conclude my first part. I will leave you now with the video about the National Power Academy. Thank you.
The Kingdom of Saudi Arabia is projected to undergo significant population, economic, and industrial growth over the next 20 years. A key enabler of this growth is the power sector, which is expected to generate a significant requirement for a highly skilled and specialized workforce in the power generation, transmission, distribution, and electrical manufacturing sectors. To address this challenge, the government of Saudi Arabia and key power sector companies, supported by academia, came together to conduct a feasibility study for the kingdom's power sector workforce. The study identified a considerable gap between workforce supply and expected demand, and recommended to build a world-class power academy to overcome this challenge. The feasibility study was completed in November 2014. A letter of intention was signed in December 2014. A memorandum of understanding was signed by the founding stakeholders in December 2015. The initial campus for the National Power Academy will be located in the eastern province of the kingdom, due to the proximity to the power ecosystem and future development of industrial cities within the region. The National Power Academy is envisioned to be a world-class, state-of-the-art, public-private training institute that will include classrooms, workshops, labs, accommodation, medical and recreational facilities. The National Power Academy will provide specialized training programs in electrical, mechanical, renewable, nuclear, operations, and manufacturing disciplines. The National Power Academy will offer 3 unique, internationally accredited training streams. The core stream will be for high school students and will offer diplomas in various power sector trades. The professional stream will offer diplomas for experienced professionals who are seeking to enhance their skill sets in more specialized power sector trades. The short certification courses will cover a wide range of technical and management topics for all professionals working in the power industry. The National Power Academy will be a one-of-a-kind, industry-led training institute, providing new training programs for emerging trades such as smart grid, energy efficiency, and renewables. World-class labs and real-life training facilities, innovative teaching methodologies, and applied research and development. The National Power Academy will bring many benefits to the Kingdom, including fulfilling the expanding workforce needs for the energy sector, reducing unemployment, contributing to economic growth, catalyzing the development of a flourishing knowledge-based economy, promoting the transition to an energy-efficient national economy. In conclusion, the National Power Academy will become a worldwide benchmark for training excellence for the energy sector and the premier destination for power sector training within the Kingdom.
Thank you. Thank you, Engineer Ahmed. It was a magnificent show and as well a presentation. The questions will be at the end of the session, as the previous two sessions. Now we will go with the second presentation, talent management within the organization is a human resource strategy that seeks to identify, develop, reward, and retain talented and potential employees. Finding and managing talent has become more complex and than ever. For today the talent is harder to find and easier to waste and lose. The organization ability to consistently seek, attract, and keep talent provides a source of competitive advantages to the organization. The purpose of the next presentation is to provide an overview on the new talent model for Saudi Electric Company. The presentation is a new talent management model at Saudi Electric Company, will be presented by Mr. Mahmoud Tomaleh and Mr. Darren John Confess. Please, go ahead. You have approximately 30 minutes.
Good, thank you. Good afternoon. And thank you for taking time to listen to us, and thank you to the committee for inviting us to speak today. You might be wondering, why do we have somebody coming from HR to present at an engineering conference? But what we really want to do for you today is we want to update you on all the changes we've been making in the last couple of years. As you may know, a couple of years ago we did a study across all of SEC to see, are the engineers and is the company happy with HR and what we are doing for you as a company? And we found out certain things, and in the last couple of years we've been making big changes. Now if you're one of the vice presidents, or if you're on the board, or if you're the CEO, you probably see us every month telling you about the changes that we've been making. But for many of the engineers in the company, you've not necessarily been seeing the changes that we've been making. That's what we want to show you today, and we hope that this will really impact you. So what we've been doing is we've been going throughout the company, we've been talking to people and saying, what do you think about what we as HR have been doing? And when we meet people, when we meet the new employees, the new engineers, we might meet somebody who says, I'm an electrical engineer, but am I going to be doing that the rest of my life? I joined the company in this small area. Will I just continue this for the rest of my life? And then we go and meet people who are in the middle of their career. Maybe they've been here 10 years, and they say, okay, now I moved up in my career, but the only way for me to move up to the next level is to become a leader. But I'm not really interested in becoming a leader. I want to continue in my career, in my technical focus. Or we go and we talk to people who have been here a lot longer, maybe 25 years, and they say, okay, now I'm a world-class expert in this area, but I'm not being compensated for it. I'm not being recognized for it. So what we're doing as HR is we're saying, how can we help the new people who join the company to plan their career? How can we help people in the middle of their career to focus on being an expert or focus on being a leader? And how can we help those people nearing the end of their career to be recognized for everything that they've been doing in the company? These are some of the things that we've been working on. So what we've been doing is we take all of HR, we take our talent model, and we've been adjusting that in order to meet your needs as engineers and to meet the needs of the company. And we want to show you some of these things. So what we do is we start with the strategy of HR. We take the strategy of the company. Ziad joined and he said we're going to become international, we're going to become more efficient, we're going to save money for the government and for the kingdom. We need to take that strategy and implement that into HR. Then we need to plan the careers of all of our people. So 35,000 employees, we need to plan how can your career support the new strategy of the kingdom, the new strategy of the company. Then we need to find the right people for those positions. We need to monitor their performance and reward their performance. We need to plan succession for everyone in this room. Who are going to be the future leaders of this company? And then finally we need to give them development. So what we've been doing is taking this talent model and we've been mapping that to everything that we do in HR. And I'd like to thank Abdurrahman Louvaid, the VP of HR. Basically, we've been changing everything in HR. And both Ziad and Abdurrahman, they've been so supportive of all of these changes. And we want to focus on some of these today and show you specifically how do these impact you as an employee in the company. There's 4 areas we want to focus on from this new talent model, and we hope that you will see how these impact you in your life. The first one is the role profiles. What we've been doing is we've been coming up with something new called role profiles, and we've done this for the top 2 or 3 levels of leadership right now in the organization. In the next year, we're going to be cascading this down throughout the entire organization. Now, that's where we need your help. So we're going to be coming to you and saying, what does it require to be successful in your position? In this company, we have some people who've been here 20 years, 25 years, 30 years. You know what it takes to be successful in your position. Maybe in HR, we don't know that, exactly what it takes. So we'll be coming to you and asking you, what does it take to be successful in your position so that when you move on, we can make sure we find the right people to replace you. So we're creating new role profiles for the entire organization. Those role profiles, they are made up of 14 different elements for every single job in the company. So what we'll do is we'll come to you and we'll say, okay, what leadership competencies do you need to be successful? What technical competencies do you need? What background, what training, what experience do you need? And we'll take those 14 boxes and we'll fill them out for every single position in the company. Once we have that information, we can use that information for your performance management, we can use it for succession planning, we can use it for learning and development. So right now we have a big project starting where we meet with every position in the company. It's kind of like an advanced job description to say, what does it take to be successful in your position? This is something we've already done. We've met one-on-one with every single one of the VPs. We said, what does it take to be successful in your position? And we've been using that in our succession planning and performance and leadership development. This is something that you're going to be seeing in the next year as we come to you and find out what's required to be successful in your position. The second part we want to talk to you about, my colleague Mahmoud will come and talk to you about the developments in career development.
Thank you, Darren. Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. Of course, Darren and I recognize that this is the last presentation before lunch, so we will try to keep it very short. Before I start my slides, I want to share with you a piece of research that was done by one of the leading global consulting companies related to talent management. The study basically simply, what does it take for any company to be able to recruit good talent, to attract good talent, and most importantly, once they're attracted, how do we keep these guys for the next 20, 25, 30 years? Now, some of these factors, as you would expect, was, having good compensation, good benefits, having good work environment, job security was very high. But the number one issue, the number one factor was having a good career path. As a new employee, I want to know what am I going to be doing the next 5 years, next 10 years, and even beyond that, you know. Now, interestingly enough, we conducted the same survey for our employees within SEC. We came up with very similar results. Maybe the order, the first 3 or 4 elements was different, but again, the number one issue for our employees was it's important to have clear career path for me as an employee to know where I'm going. Now, having said that, you know, we created what we call the career progression model for every single employee in the company. All 36,000 employees are covered now under this new career progression model, which shows the career path. Now, as you could see here, we divided these into 3 clusters. You know, the first one being the professional. An example, you know, if you're an engineer, if you're an IT professional, an accountant, a lawyer, you know, or basically if you have a college degree, you belong to the professional track. The second track is for our technicians, our power plant operator, instrumentation control, mechanics, electricians, you know, we have a career for technicians. And the third one is for the frontliners, you know, simply industrial security personnel, meter readers, clerks, and things like that. So this is the first point that takeaway I want you to have is every single employee in the company will have a career path. Now, this is very, very big challenge, as you could imagine, especially related to the number of employees we have. And we have more than 220 job families in the company that covers more than 1,200 unique jobs. So to be able to establish a career path, competency-based career path is a massive project that we'll be working with you, as company leaders, as also the experts and the professionals. We'll be working, as Darren mentioned, during the coming year with you to be able to do that. Now, since a lot of engineers, a lot of professionals in this room, I would like to focus on the first segments. Now, in the old days, as you might know, that the only way was for a professional, for the engineer to progress in the company is to simply leave this technical track, leave the professional track, no matter how good of an engineer you are, due to the limitation in grade codes and things like this, you end up leaving that and joining the management or leadership track. And in a lot of cases, we end up losing good expertise, we end up losing good engineers, and we may or may not get a good leader. See, this is the sad part about that. So the new career path or the new career model offers, if you are an engineer or accountant or a lawyer, and you're good at what you do, and you want to continue to progress for the rest of your career path, for the rest of your career life, I should say, as a professional, as an engineer, now you have the opportunity to do so. So we created this career path that at the first maybe 10 years of your life, you develop the foundation. You basically, this is what we call like a career integration program. You widen your experience in your area of expertise. So if you're an engineer in generation, you know, you get exposed to operation, maintenance, engineering activities, you build the foundation, then you come to a decision time. And at that point, this is a discussion that happens between you and your supervisor, and you decide which track you want to take, you know. So of course, this will be based on your capability, based on and the company needs as well. So basically, if you're an engineer and you want to, in generation, for example, and you want to continue to be an engineer, specializing in one critical area, important in generation, for example, vibration, you have the opportunity to do so and continue to grow until you reach grade code 56, you know. Now, for those of you who don't know our grade code system in the company, this is equivalent to a department manager of a large department, without having to be a supervisor. You could continue to be an expert in your area. Of course, projects, we have, as a company, we're a technical company by definition, we have projects, multi-billion-dollar projects, so we definitely need an expertise in project management, so this will be one of the tracks that's available. And of course, last but not least, those, of course, who are interested to continue in the leadership track, this will be available for them. Now, we think of these career paths as the highways. Now, in order to progress from point A to point B on the highway, you need a vehicle. These vehicles are what we call the career development programs, long-term career development programs. Once again, everybody in the company, all 36,000 employees, will be part of a large development program. We created these 6 development programs to cover everybody in the company. Now, the basic methodology of the development, I will just summarize it, that once all employees will be part of that, will be part of the long-term development program. The level of development starts from wide to narrow, so you will be developed as a generalist, then as a specialist, then as an expert. Of course, not everybody will have a chance to do that. You must have what it takes. You must have the capabilities, the technical competencies to be able to grow in this model. We're not saying every professional will eventually make it into the expert, but we're saying those who have the capability and the desire will be able to grow into the expert. And obviously, we will use a large variety of development tools, starting from training courses, to the on-the-job training, to the coaching that has to happen between the employee and his supervisor, and many other tools, such as in some cases we have a master's degree with world-leading organization in some specific discipline, or we have partnerships with companies like GE, like Siemens, that we offer opportunities for some of our specialists or some of our experts is to join these companies and work hand in hand with their experts to learn directly from them. Now, I think I talked about the development for the experts. We're not going to forget the leadership developments. We are very proud to report that we have established a world-class leadership development center in Riyadh. It's been operating since beginning of February 2015. Now, what distinguishes our center, of course, we have partnerships with world-leading organizations such as Michigan, Ross Business School, Michigan University. We have partnership with GE. Matter of fact, we built our center based on their long experience in the famous leadership center that they have that's called Cortenville, known as Cortenville. And of course, we have a partnership with one of the leading management companies, RBL. Now, in addition to that, we have established an advisory board consisting, as you could see from, maybe you recognize some of the faces there, or if not the face, at least the logo. This board is consisting of CEOs and leaders of international companies like GE, JP Morgan, and then deans of top-tier universities like MIT in Michigan. And of course, the purpose of this advisory board is to overview everything we do, make sure that they keep us in line, we keep what everything we're doing in accordance with the best practice. Another major thing that distinguishes our center is senior management engagement. If you come to the leadership center at any given day of the week, you will either find Ziad himself or you'll find one of the vice presidents highly engaged in the development activity. So this is not a training center. We don't deliver training there. We create leaders. In doing so, by engaging them in very challenging projects that are directly supervised by our senior management, CEO and vice president. Now, to align with the new vision for the company, we have established a new leadership model, a new leadership competency model. Now, a couple of things I would like to highlight here. Obviously, the first part, maybe this model consists of two parts. The first part is general competencies you expect to see in every leader on the face of this earth. Whether you work for Google or for Aramco or for SEC, there are certain competencies as a leader that you must have. Now, I could summarize these, by being strategist, executor, talent management. So basically, every leader must know where we're going, how do we get there, who do we take with us, and who stays in the company once we leave. So this is basically the first half of our model. The second half is something specifically unique for SEC. Now, we conducted extensive meetings with our major stakeholders, our major customers, our board of directors, every leader in our company, department manager and above. We came up with what is it that we want to distinguish SEC. When you say SEC, we want to be known for these three differentiators, these three core competencies, specifically for SEC, being customer focused, efficiency, and performance and excellence. And obviously, I think everybody in this room could relate that as a utility. These are very important for us. Now, we incorporated this, in all the curriculum, all the development we do right now is based on this. In addition to that, we incorporated this in our performance management system. So right now, this is a major part of the company's culture, and of course, it's going to take time to build this culture, but eventually when we say an SEC leader, we want everybody to think of these three differentiating competencies. Now, our main program that we offer in our Executive Leadership Center is what we call the Targeted Talent. So Targeted Talent is nothing but a special program for the high-performing leaders, for the people with high potential at every level of the organization, starting from an individual contributor all the way to an executive vice president in the company. Now, so of course we will continue to have our normal or regular leadership development programs through the succession planning system, but in addition to that, we will have this accelerated program, which is Targeted Talent Program. Today, we have more than 165 employees in different leadership levels participating in this program. Now, I guess last thing to say about this slide here is we tie, and there's a complete tie between the output of this program with the succession management. And like I said, this program is like 10% is conducted through training courses, high-level training courses, but 70% of the program is done through working on action learning projects. These projects are carefully selected by our senior management, and we have 20% of this model is implementation under the supervision of executive coaches. So each group of leaders, will be assigned a dedicated executive coach to ensure that their program is implemented in the right way. Okay, at this stage I would like to turn it back to Darren to cover the succession planning.
So when Ziad first joined the company, one of the things that he kept on saying, and I heard this every time I saw him, was, do we have enough good leaders in the company or not? And the board kept asking him that, and everybody was asking this question, do we have enough good leaders? And everyone you asked would give you a different answer. Some people would say, oh yeah, we have lots of good leaders, and some people would say, oh no, we don't have enough good leaders. And so what we wanted to do in succession planning, and this is what we started doing a couple of years ago, we started to assess our leaders to say, do we have enough good leaders in the company? Who are those leaders, and how can we prepare those leaders for future positions? We know that we have a lot of people who've been in the company 20 or 30 years, and they're experts in what they're doing. But are they able to transfer those skills to the next level. If you look at all of these parts of HR that we're working in here, we're looking at the strategy and the career development and the recruiting and performance and succession and development. All of this is about, do we have good people in the company, and how can we make sure we put those right people in the right positions at the right time? So when we look at what we've been doing for succession management, we've been meeting every week, every month with the VPs and with the CEO, and we've been going through using certain tools to assess, do we have good leaders, and what are we doing to prepare them? The first part of that is we've created something called a 7-box. Maybe you've heard of the 9-box. A lot of companies use a 9-box. What we chose for our company is to use a 7-box. The reason for that is because when we had a 9-box, we had everyone stuck in the middle. So we didn't know, do we have good people or not? Because almost all of our people were stuck in the middle of the box. So what we did is we created a 7-box, and we look at what is your performance on your current job, what is your potential for the next level. And we want to say, who are those people who are high performing, high potential? So we have 4 different assessments we use for this. We take your boss's assessment of your performance, and we take a 360 assessment of your performance. Then we take a boss's assessment of your potential, and an assessment center assessment of your potential. We combine those scores, and we say, who are the people who are high performing and high potential? Now for everyone right now, from department manager and above, we have a 7-box. We can tell you every single person in this company from department and above who's high performing and high potential. That means you're in the green box, in box 1 or 2. If you're in box 1 or 2, 2 things happen to you. One is, we send you to the Executive Center for Leadership Development. You get extra development, you get more focused development because you're one of the great guys in the company. Secondly, we put you on a pipeline. We're going to get you ready for a new position. So we find out who our top talent are, and then we take those top talent and we put them on a pipeline. When we put you on the pipeline, we're seeing, are you ready for a specific position? Now for every leadership position in the company, we want to have 4 people. We want to have somebody who's ready now, somebody who's ready soon, and 2 people who will be ready later for every single leadership position in the company. Now, a year and a half ago when we started this, we had about 30% of our pipelines, 30% of them were healthy. 30% of them had enough people. Now, after a year and a half, we have 70% of our pipelines are full. 70% of our pipelines have enough people. And we've been meeting every 6 months with the CEO and the VPs to review every single leadership pipeline in the company and make sure we have the right people. And we have so much assessment data which helps us to know if you're the right people. Once you're on a pipeline, then we go and we actually assess, are you really ready for that role? Imagine that Abdurrahman would put me on his pipeline. Okay, fine, I'm on his pipeline. But now he has to assess me according to his role. Do I have the leadership competencies necessary? Do I have the required background? Do I have the technical and functional competencies? He's going to assess me according to all of these areas to say, am I ready for this position? Once he's done that, then I can start being developed for that position. And then, like I said, every 6 months, we sit from 8 in the morning until 8 at night with the CEO and with all the vice presidents, and we go through every single pipeline and we say, is this the right person here? Is this not the right person? And how can we develop these people? So the last 2 times we held this session, we literally sat from 8 in the morning till 8 at night, going through every single pipeline to see, do we have enough people? Do we have the right people? And how can we develop these people? And as I said, we've had so much commitment from the vice presidents and from the CEO. They're committed. They come early, they stay late, and we go into a lot of detail. So I hope this encourages you. Some of you, you don't know, am I on a pipeline? Am I not on a pipeline? Are they thinking about me? They're not thinking about me. Some of you guys, I've never met you, but when I see you, I'm like, oh, I know everything about this guy. Because I've heard them talking about this guy for 45 minutes. I've heard them talk about every detail about your life for 45 minutes because they're considering, are you the right person or not? So be encouraged that the company is putting a lot of time and effort into thinking about who are the next leaders of this company. So are you still confused about your future? You're thinking about where will I be going? the tools that we're creating, some of the ones that we've described to you, so the role profiles, the career paths, the targeted talent, the pipelines, these tools are not being created for us. These tools are being created for you so that we can help you plan your career, and we can help you be developed in your career, and we can make sure that we have the right people in the right place at the right time for the company. Well, we want to ask from you, and Mahmoud and I want to ask this, and I think Abdurrahman wants to ask this from you. Please take charge of your career. If you don't know where you're going, you don't know what's next for you, go and sit with your boss and say, what's next for me? He says, oh, I don't know, I'm waiting for HR. No, don't wait for HR. We have so many tools that we want to use to help you plan your career. We need you to take the initiative, to go and push your supervisor, to push your boss, to push your VP and say, what's next for me? I want a development plan. I want a career plan. 3 minutes? I only need 3 seconds. Okay? We're doing all we can to help you plan your career and be developed for your career. I think we've made big steps forward, but we need you to take the initiative. Don't say, I quit. I'm going to join Aramco because I don't know what my career is. No. Come to us or go to your boss. You can join them if you want, but please, first, come to us and say, what's my career? What's my development plan? What's my succession plan? Because we've been doing a lot of work to help you in that area, and I think we're making big steps forward. Thank you so much for your attention.
Thank you very much. Of course, Mahmoud Tamaleh, as a talent management expert with more than 25 years of experience in the field of learning and development, talent management and leadership development. He is the career development division manager in Saudi Electric Company. Of course, Mr. Darren, he was the world-class leadership development expert who has an extensive experience working in a talent management, leadership development and executive assessment. Currently, he is leading Saudi Electric Company in a new approach to execute succession planning and supporting the transformation of HR. I would like to thank our presenters. We are willing to have any questions. Please go ahead. Can't hear you. صوت لو سمحت. Still.
No problem. I will raise my voice. No problem.
Okay, now.
My question is to the Mr. Darren. What you're saying, we've been hearing it for almost 2 years, and it's nothing new actually. The question is, when all the things that you've been saying will be implemented officially, and we see it when we go to work every day, we can see it in the real. You said ask your boss if you are worried about your future. Most of the employees of SEC, when they ask their boss, they don't have an accurate answer. So there is a confusion.
Okay, good. Thank you for your question. So the question is, when will this be implemented? And if I ask my boss and he doesn't know, then what can I do? So we can say, first of all of the concepts that you've seen here are being implemented at the top 3 levels of leadership. So we've been doing this for the last couple of years. We're doing the succession planning, we're doing the leadership development, we're doing the career paths. All of them are happening right now, and all the tools are currently being used. Our challenge this year is to cascade this down through the rest of the levels. So we can say, we're not waiting to start. We've already started and we're already doing this. So if you go and ask anyone in the top levels of leadership, they know all about this and they're very familiar with it and it's already working. What we have to do this year is we have to cascade this down to the rest of the levels. And this is where we actually need so much input from you and from the rest of the company. So we're going to be creating technical competencies. We're going to be creating role profiles, and we're going to be doing succession planning for the levels going further down. But this is a project that's ongoing. We said we have to start with our leaders. If we start at the bottom and work our way up, it won't work. We have to start at the top and work our way down. So we do need you to be patient with us because we can't do this immediately. It takes a lot of work from our side, but we are moving quickly, and for the top 3 levels, we've already been doing this.
Okay, just a quick follow-up on this question as well. Well, Darren explained what have we been doing for the leadership, you know, and I'm sure if you ask every leader, they will tell you everything we said. Now, the other stuff, you know, I'm pleased to tell you, it's not just a theory. It's not just a design model we came up with. In the past year or so, we've been, first of all, this model that I presented has been approved by our senior management. Secondly, we're currently working on aligning the organization structure, revising the entire organization structure to make sure it's aligned with our model. So when we come to you and we said, as an engineer, you can reach to or climb to grade code 56, you know, we could look you directly in the eyes and we say we're honest with you because this is already approved in the organization structure. We have a team that's working devoted almost full-time on creating technical competencies because this model will not work without having exact technical competencies for each job family. So the team has been working for almost a year now, and we're almost 40% completed. So lots of work happened last year, and we will continue obviously this year to make sure that this model is completely implemented. Thank you.
Any more?
Assalamu alaikum. Global Dimension. First of all, I would like to really comment about this development model that we have. It's really impressive. I mean, excellent one. My point here, we would like really to engage, especially the young people who, you know, in the department, say, bottom of your hierarchy, to be really engaged and to see a hope in the future. The one that you are talking about is really beautiful, especially for the leadership and how to make the company moving forward. But the people in the bottom, if they didn't engage into it, they don't have a hope. When I say hope, it means like I'm a new employee of a company. I would like to see where I'm going to go after 5 years, 10 years from now. Even I'm not going to be a leader in this company, but I might be a leader in another company because they are almost the same skills that you need. I think it's better for them to know that each step for them in terms of training, development, it goes to them. So it's like I do invest in myself as an employee in the company, how I would like to be a better employee in the future. The second point is for Mr. Ahmed about the academy. I'm very happy to hear that a number of companies in Saudi Arabia that are working together and collaborating together to bring a good talented Saudi who will be really working in this field and hopefully will be coming future leaders for our companies. What I saw from the consortium, let's put it this way, there's a number of companies or organizations in Saudi Arabia. They are really heavy one, like KCare, King Abdullah City for Renewable Energy. I don't see it within your organization. That's just one point here. Thank you.
Okay, thank you for this question. I will start the second part of your question. In the fact, what I have said or show you here is basically the framework that we have. However, we have several virtual teams. One example is the SEEK. The efficiency team is part of our program. And they work with us, they put the human capital development as part of our initiatives here. So we are working jointly. The similar thing related to some of the traits, like the nuclear. It is as initiative in the kingdom is hand over to the key care. So this is part of site teamwork, which is basically we work virtual with several teams. But maybe the presentation is not detailed enough to give you how much efforts we are doing in this perspectives. Similarly, if we, for example, mention about the role of the academia, for example, presented by KFUBM, they are working with us. They are also involved in the workshops, not only just matter of trades and program. We are talking one step further to go and evaluate even the accessibility, the flexibility, the operation, and the other things that related to even the physical tools that will come and fit in the workshop. But I agree with you, the KCARE, other like SEEK, they are part of this program, and we are going as we go, because as you know, nuclear is not a focus now, but it is part of our strategies in the National Power Academy. I hope that's a clear answer for you.
And regarding the engagement issues, so one of the things that we're planning to do to really increase the engagement is those development programs. As you saw, all 36,000 employees will be in a development program. Those development programs will take 9 or 10 years for each development program. Now we have 6 development programs, but the first 2 we're going to start with is in the professional track, whether early professional or expert professional track. Now we already have a PDP program, but it's only for the very beginning of your career. And we have an expert program, but it's only for a small number of people. In the new programs, the expanded version of that early career track will cover everyone who's in their early professional career, and it will cover everyone who's in the later professional career, which is the expert track. So we believe in terms of engagement, the first 2 programs that we're going to do, which will be happening this year, are in the professional track for either earlier or later professionals who are non-leaders. We've already done a lot in terms of leadership development. I think we're doing well with that, but we need to focus more on the rest of our professionals. And those are the people that we're actually worried about losing. So, you know, when people say, well, we're losing good people, it's those people who are in the professional track that we need to focus on. And every single one of them will have a development program. So we hope this will increase their engagement.
Any more? One more question. It looks like everybody hungry. It looks like. Okay, we conclude. Then we would like to thank our presenters, Ahmed Al-Isa, Engineer Ahmed Al-Isa, Mahmoud Tamale, and Darren Confus, John Confus. I'd like to thank you all, and thanks a lot.
جزيلا للمهندس فهد العسوس. يكرم الآن المتحدثين.
في صحن باقي انت حاطط صحن
تفضل.